Nope, we started late. I forgot to hit the button, but we still gonna make it on time. We are still here. We've made it. Still on time. I know people aren't in yet. You know, I understand. I didn't I forgot to hit the button. I was downstairs making a little bit of, you know, a nice cup of Joe. So if anyone's on, I will give people a little extra time to get on. Let's close this up a little bit. You know, we don't like natural light out here, but all my stuff is all messed up. 1 second, I don't need the stream manager. I need the chat. All right, so if anyone said anything in the last, oh, there we go. Oh, no. Okay, I can see it. I found it. What's up, MJ? First again. You know, gotta get that scoreboard going. Sharky Shreds, absolutely. On time crew. What's up? What's up? We still made it on time. What's funny is I set everything up. I just didn't hit the button. I didn't hit the button today, but no big deal. I gotta give this 4 minutes to brew anyway. Oh man, the top got dirty. But yes, welcome to deCoded. Welcome to the what is this? It's not penultimate yet. Next time it's penultimate. But you know, we're finishing up week 7 of 8 right now for the apprentice level of deCoded. So again, you're almost done your journey. So congrats, welcome. Hope everyone's doing fine today. I'm doing pretty good today, actually. I'm doing okay. You know, work wasn't crazy. This hasn't been a wild week of work at all. Been working on a lot of stuff. One thing, the only thing that's been stressing me out a little bit, not stressing, but is my talk on Saturday. I'm hyped for the talk. I'm hyped for the content. I have to do, there's a fun piece of it, and I'm trying to make sure that I get the, there's a little bit of coordination I got to do over here with my Stream Deck, my Go XLR mixer, all this stuff. I got to do a lot of coordination throughout the talk. You know, it's a bit ambitious. We're gonna kill it. You know, I just got to find some practice. It's also, this is going to be a great weekend. It's going to be Father's Day weekend. So I'm going to get to spend a little time with the family. And it is my wife's 30th birthday this weekend. So that's going to be exciting. We're trying to find some time to celebrate that as well. So a lot going on, but all good. Yes, we're still on time. We still made it. And it was close. Got to be honest, you know. Had me there, you know, had me going for a second, but we did in fact make it. But one problem that's happening right now. Okay, there we go. Never mind. I got it. Let's host F this. My VM was acting all the way up. But today we are doing some fun stuff with TDD, with test driven development, a fairly exciting topic. I enjoy this topic. Actually, the music's probably pretty loud. Oh no, it's not. It's not. Oh, things are working out. It's not because this is turned down low. Now it would have been very loud. It would have been just like this for a long time, but it's not. We got it at a reasonable level. Wise change this song. Yep. I definitely got to do something special for the missus. We'll make it happen. Yeah. Yes. Her birthday's actually on Father's Day. It usually falls on the same weekend. Well, it falls right around that time every year. So we're gonna find something to do. You know, unfortunately, we both had our 30th birthdays during, you know, in quarantine. You know, she's a little bit more fortunate than me, and we're in half quarantine right now. Like, they're opening up gyms tomorrow, which is wild. Well, not in the city. We live in Baltimore City. The gyms are not open here, and all the restaurants and stuff. But in the county, they are, and we're really close to the county as well. So, sorry, this got all tangled, and it was bothering me a little bit. So yeah, so we're gonna get to be able to hang out, and you know, see some people and have a little fun and enjoy ourselves a little bit, because we're both pretty busy. So I'm pretty excited that we're gonna get just a little time to relax and to chill. But yeah, let me get everything together. I think everything else is set up. The classroom drop. Let's see. 1 second. Maybe not. There are slides. Should have dropped. Let me see. What's today? Today's number 14. 14. Oh yeah, TDD. Test driven. And so what's exciting? What's going to be not exciting? But what's going to be good about tonight is that the reason that we chose exorcism as the tool that we were going to start practicing with is because we said before they practice test-driven development there, and so they're going to do a lot of the hard work for us tonight. Exorcism is going to have that done for us, and so we're going to focus on the concepts. TDD is something it takes a while to get good at. I think a long while to get good at, and you may not ever get good at it, but it's a very interesting concept. But again, we're going to be able to use it without having to really stress about it, so it's going to be nice. Let me get you those slides real quick. Create material slides, Google Drive. I gotta change the name, but whatever. Post it, and so it should be there. I'm gonna change the name up real quick as well to, what is this, 14 TDD. We'll leave it at that. So now you can get in. Let me get you the share button. Let's get that link out there. Whoa. Change link. Let's get it to be anybody. And let's paste this on in here. Oh, what time is it? 7:06. Yeah, we can let's just plunge it a little bit. Let's let's do the thing. There we go. Sometimes it's satisfying, sometimes it's not. I'm experimenting with different amounts of different water to coffee ratio. I'm also, let me see if you guys can hear the pour up. Very we're sound engineers over here. Hopefully somebody recorded that, and you can use it in your, feel free to use that as stock sound in whatever you do. It's pretty watery, to be 100% honest. But I don't know why. I added more coffee than usual. What tastes, let me, hold on. I don't know. It's not hitting like I thought it would hit right now, but it's all good. Got my cup. We'll get my water later. But yeah, I'm gonna try out some pour over coffee soon. I'm gonna get a pour over kit. I hear really good things about the what's that thing called? Let me get to Academy View real quick. Let me show you guys the V60 coffee thing. I forgot what it's called, but it's like fancy. Yeah, the Hario V60. And I was gonna grab one with their little filters and try to do some pour over because I heard interesting things about it. As look at all these great reviews. And I read something about, the carcinogens of unfiltered coffee. Like, this is not filtered, using a French press. I was like, man, we'll see. I just wanted the easiest thing to make coffee with, not filters or anything. It's kind of nice to just mess around with. But yeah, the title's supposed to be test-driven development. What is it? Did I spell something wrong? The fingers are fat. Test-driven development. With exercise. Yeah, it is definitely supposed to be exorcism. Oh, you know what it is? It's because I set the title for my iPad today, and I bet you my iPad auto-corrected it. Exorcism. There we go. It should update. I think that's how it works. I think it'll just, boom, fixed. Like nothing ever happened. But we can exercise here too. Stretch a little bit. I have a Game One shirt here. No idea what Game One means, but it was, I have the shirt. I think my mom gave it to me or something, I like free clothes. I like to make a 70% decaf. Hey, I'm cool with, the thing is that I'm not a huge, I love the flavor of coffee fan. Like, I drink it because, I drink it when I need it. And I also use it, so I stopped taking pre-workout when I do work out. I stopped taking pre-workout in favor of black coffee. That's usually the only time I'll drink coffee if I work out that day. And then I will allow myself a cup of coffee, anytime throughout the day if I need it. But yeah, definitely try to limit it. I might I think I'm gonna keep doing black coffee before workouts, but for the day I might start drinking tea, green tea. We'll see what happens. I surprisingly never have trouble sleeping with when I drink coffee. Even if I drink coffee late, I don't really have any trouble sleeping. And coffee does not work for me if I'm already tired. Like, it doesn't wake me up at all. So I got to drink it, like I got to preempt my tiredness. Yeah, right. I'm definitely gonna try out tea. I mean, I like tea. I love tea. Coffee is just super convenient everywhere, like where I work and stuff. So I just have been getting the coffee, and I kind of kept it up. But I might switch over. I might switch over to tea. We'll test that out. But let's get started tonight, so we can get kind of hands-on and learn a little bit about test-driven development. And really, we're going to learn about a little more than that. We're going to learn about software testing as a whole, just very lightly. Very lightly. Hold on, let's get on some Burt's Bees. This is going to ensure that the words come off of my lips as crisp as possible. There we go. So, intro to test-driven development and software testing. Testing 1, 2. So I think it's important to throw in software testing at the end of here. I think that one of the problems with test-driven development, or when it's usually discussed, is that no one ever talks about software testing and the software testing ecosystem as a whole. And we're, again, like I said, we are going to go into this very shallow. Software testing is actually a very deep topic. I did not know that. I had to be schooled on this over the past few years. It's very interesting. It's a very interesting field in itself. To be 100% honest, it's difficult. I find it to be difficult, but yeah, it's kind of cool. A lot of people think about it one way. We're going to learn about some of the other ways to think about it tonight. So a couple of slides, and then we'll hop right into some code. So what is software testing really? So software testing is a process. So this is, our native Wikipedia definition that we're going to grab. I don't think this one came from Wikipedia. I should probably start crediting people for these things. But software testing is a process to evaluate the functionality of a software application with an intent to find out whether the developed software met the specific requirements or not. And I'm going to stop there for a second. So when we're saying test software, you're not testing, everyone's, just make sure it works. So how do you know it works? You know that it works when you test it against its desired functionality. So you take, whenever you build something, you have a desired piece of functionality that you want it to do. You have a desired end goal. You have, a thing that you want this piece of software to do. And that's what you are testing against. You're testing to see if it does what you say it's supposed to do. And you're also testing to identify any defects that may be associated with that to ensure that the product is defect-free in order to produce the quality product. So you're not just, the piece of code working is one thing, but you're really testing for it to do the thing that you want it to do. And that is something that people miss very often, with the it works paradigm. And we do say make it work, but when you're making it work, the thing that qualifies it for working is if it does what we want it to do. And yes, you are correct. The crash test dummy Sin City has in fact had a little too much coffee. Not too much of this coffee. Like I said, this one's a little weak, which is weird, and it may sneak up on me because I made a similar ratio the other day, but I think I let it brew a little longer with a different blend, a different set of beans, and it hit me. It definitely. So I was hoping this will do the same, but it's okay. Yes, great question, Sin City. Those slides are coming up very shortly. We'll absolutely cover that. So this is what people normally think of when they think of software testing. At least what I found, this is what people are normally thinking about. So manual testing, this is a type of testing. It is absolutely an important type of testing. It has its place, it does certain things, but this is that testing by hand. This is saying, hey, the software is supposed to, when you click on this button, it's supposed to go to this page, and I need to test that functionality. So I'll bring up the application, I'll start it up, I will click on that button, and I will ensure that it goes to that page. This is great. Manual testing absolutely is great. You're using the application in the way that the end user is likely going to use it. But this is a relatively cumbersome and slow process, not very scalable, to be 100% honest. And like I said, a lot of people, when they think of, when they hear terms like QA, when they hear terms like software testers and those jobs, some companies, that this is what they have people do, especially like video game companies. Video game companies have their QA testers for the most part. Hey, You're gonna get a build of this game. I want you to manually play the sections of the game, report back, try to do this, try to do this. You have your different test cases. You're trying to do these things manually and reporting back on what happens. And yes, this is a form of testing. It's part of the testing process, but it is absolutely not the whole story. But just want you to know that there is a term for that hands-on testing. And then we're gonna get into automated testing. So this is where software gets powerful. Software allows for automation, and automated testing is it's the process of testing software using an automation tool to find defects. So it's taking instead of looking for these things manually, instead of trying these things out manually, you are using code or tools to be able to go through cases, go through scenarios that you define, to see if code operates or codes or systems or whatever it is operates in the way that you expect it to. And these tests don't do anything but that. They perform an action and they provide you output. They provide you information about what occurred when it went through this automated process. And so this is basically what we're going to be mostly what we're going to be learning here. This is the type of testing that we're talking about when we talk about test-driven development. It's putting in this type of testing. And so let's break down some of the automated testing. And I'm only, like I said, this world of testing is huge. And I'm going to give you guys some resources to dive deeper into the world of testing. But I'm just going to cover the stuff very specific to tonight, because I do think when we get into the stuff tonight, I think the general concept is easy, but like really kind of understanding it in practice is kind of hard. So we're going to spend most of our time in there rather than covering large swaths of testing practices. But unit tests. Unit testing. Unit testing is a type of software testing where individual units or components of a software are tested. The purpose is to validate that each unit of software code performs as expected. So unit testing is testing a piece of functionality in isolation. And when we start to break down the scope of things that are being tested, there could be it can be hard to draw the lines, but unit testing right now, for just right now and tonight, I want you to think about unit testing being testing the function. So like an actual function, a singular function. We said that a function is, that packaged up piece of code that only runs when called. But functions are generally designed to do, one thing or have a limited scope of actions. And a lot of the times we're going to be writing unit tests to test each of these functions. And tonight we are going to be doing specifically that. But unit tests a one unit of code, one unit of functionality in your code, and kind of isolation of everything else. And so like I said, this is unit testing is what people are talking about. This is specifically what people are talking about when they're talking about test-driven development. They're talking about unit testing and writing tests to test functionality of your code before you write it. Now, the other type, I don't want to say other type because there are more, but another type of testing is integration testing. Integration testing is a level of software testing where individual units are combined and they're tested as a group. So this is larger swaths of functionality. So rather than testing the unit of code and its functionality, this can be more like feature testing and testing, when the code is combined to do the task that these different pieces were created to do. We're testing to see if those things work. And again, the line between unit testing and integration testing can sometimes be tough. Like I said, usually unit testing is scoped to just that isolated piece of code. It doesn't need information from anywhere. If you need to do anything with it, there's ways you can fake data and stuff like that. If the code is getting information from outside, you can kind of fake those things, and that's okay because you don't care about the data itself. You only care about that little piece of code. Here, you want to test how the code works when it's running together, when these things are interacting. So those are the two main forms of tests that I want you to know about right now, only right now. These are not all the tests at all, but these are two probably most common and important ones that you're going to run into in your career, and that you would probably have to write as a developer. These are scoped usually to the developers in most cases. And just to highlight the difference between these a little bit, because SimCity asked about this a little bit, here's the difference. This is a common paradigm on the internet. There's whole subreddits related to this. There's all kinds of memes about 2 unit tests, but 0 integration tests. And hopefully memes like this can show you what that means. And so take a look at this GIF right here. We have a deadbolt lock, and we have the part that locks over on the left at the sliding bolt, and that works. That you know, we've gone through it and we've seen that works. We got that functionality down. It does what it's supposed to do. It slides from left to the right, and we can lock it. We can slide it back down and lock it in place so that it stays there. And we've also tested the thing on the right, the other lock per se, where usually if this door was working properly, that would keep the bolt in place and it would keep the door from moving forward or backwards. You can test that thing in isolation. So if you test both these pieces in isolation, they both look good on paper. They look great. It looks like it's installed properly. The lock does what it's supposed to do. But when you test them together, when you put them together and you're not testing each individual piece in isolation anymore, you now get something that doesn't work. And honestly, and the other piece of the unit test might be the door and not the other side of the lock, but whatever. It's you know, everything here works in isolation. The door opens, the door closes, the lock, the sliding lock slides, it locks in place, it goes into a receiver, and it stays there. But the door itself slides the wrong way. So these things were tested in isolation, but not together. And hopefully that helps, you know, identify it a little bit. There's a lot of these out there and they're pretty funny. And you know, whenever you're creating these things, this is why these different level of tests are important, because it is important to know that your code functions in the way that it's supposed to function. But later on, you're supposed to make sure that it also functions together with other pieces of code, because that's where you find the most interesting things. You know, I can't tell you how many times I've developed things where the pieces work fine, but altogether they do not work fine. All right, let's see. The best golf ball would fail most tests for basketballs. Absolutely. That's really good. I like that. Always edge cases. And so that's what it takes to become a good tester, is being able to, you know, thoughtfully think about those test cases, those edge cases, and find those things that work. You can't get them all, but you really can strive to kind of get there. Whether in test, no testing, or unanticipated environmental factors. Yeah, yep, those are all those edge cases that happen, 100%. Like testing components on a car and then testing the car as a whole as an analogy. Yes, 1000%. Those components on the car. So on a car, you have a starter. And yes, your starter may start. It may turn when the electricity is applied to it. Your starter may turn, but when you put it on, maybe if you have a small starter and you put it on a big giant truck with a big giant flywheel, maybe it's too weak to turn that entire flywheel. And so that integration test will show you that where your problems lie at. And so yeah, it's testing those components together. I really like that. I like all of these analogies. Really, really good. Sometimes it's hard to know what's a bug and what's vulnerability. That's true. What's up, Matt Peanut? Yeah, it definitely can know. It can definitely be tough to decide between those sometimes. A lot of the times those vulnerabilities will be published, but if not, I've run into situations where that was the case. Well, but it's similar to how Flask is able to allow you to use Python. No, not really. Not really diarrhea. Like, not really. Well, nah, not really. That's I'm trying to tie that in, but I'm maybe. I'm not finding it. What's up, Aviato? What's up, Capra? Welcome. What's up, Action Wanson? What's up, Jose 254? Anyone for coffee? I love it. That was 7 hours ago, but welcome. Okay, let's get through this real fast. So we talked about just very lightly that when I tell you that was the lightest introduction to software testing ever, it really was the lightest introduction to software testing ever, but I think it's okay for now. But what is test-driven development? This is the buzzword right here. What is TDD? And you'll actually get a surprising number of different responses if you look this up, because in its, I think in isolation, test-driven development seems weird. So people generally have tried to like add in some reasons why it's great into the definition of it, rather than leaving it up to what it is. So we're gonna keep it pretty simple today, because there's a lot to talk about when you get to test-driven development. But test-driven development, or TDD, it's a methodology that's very important. It's a methodology in software development. So it's a way of doing things in software development that focuses on an iterative development cycle. So iterative, we've used iteration before, like going through iterating through collections, going down the line in a list, but iteration. So doing something once and then going back and making it better and releasing a version 2 and then a version 3, making it better in pieces and waves. But it's a development cycle where the emphasis is placed on writing test cases before the actual feature or function is written. So TDD has evolved. It is much larger than that. It's really a methodology that just really gets testing at the forefront of the software development process, where things kind of go a little more hand in hand. But the goal of it, the thing that it's known for, is that instead of writing code, you get your requirements that says, hey, I need you to create a button. That button needs to be read, and when it gets clicked, it needs to go to this website. Normally you go say, cool, let me go write my HTML, let me write my CSS, let me put whatever JavaScript I need in here, and then I'll write automated tests to make sure that this thing is proper. Test-driven development is actually doing the opposite. It is saying, hey, before you write any code to implement this feature, we need you to write tests first. So you're gonna write tests. You might say, hey, how do I test something that doesn't exist? That's the goal. The goal is to write something that fails. You want to write tests that fail. And that's easy to do. Any test without code going into it is going to fail. But you want to write these failing tests. And what this allows you to do is it allows you to be thoughtful about what you're doing. It allows you to really think about solving the problem rather than the implementation of code, which is kind of nice. It can be very beneficial, but it's a different paradigm, and it is difficult to do well. But I do think it's a good practice. I think it's something that people should try to do every now and then. And if it's something you get good at, I do think it's worthy of implementation. There have been a number of studies on whether or not this is truly effective or not. A lot of people used to swear this is the best way to do things. The data has shown that may not be the case. It doesn't necessarily create less bugs or anything like that, but it is an interesting way of going about it. And I do think it's a good way a lot of people skimp out on their testing, and testing is pretty important. It's a good way to put testing at the forefront of what you are doing. Exactly, Triqueta, 100%. That's what we're gonna be doing tonight, is looking at the test file before we do any of the work, and it's going to guide us. And I'm going to show you tonight how it's going to guide us, and how we can use this process to do some pretty cool things. It's very interesting. There's forgot what it's called. I did there's like a national day of code or something, and last year they have these events all around the country during that time. And last year, or maybe the year before, I went to one, and they were specifically covering test-driven development. And we had to sit down, and we actually, what they wanted us to do is develop an algorithm for Conway's Game of Life. Take a look at it. It's an interesting paradigm about, I think it's about like the way that like life can spawn, Conway's Game of Life. And what we did is we did a couple of iterative rounds of breaking down what the problem is, breaking down what needed to happen, and writing tests. So having everyone write tests, and then having to practice, and then breaking down the room, and then having only half the room write tests. And then they actually passed everything off. They would write all the tests, and they passed off the code to everyone else in the room, and the rest of the room had to build this code based off of other people's tests, which is a very interesting it was a very interesting exercise, and it absolutely made the process much easier for me as someone who at the time was having a lot of trouble kind of thinking about how I would implement this. But because we had broke down the problem before, not thinking about code at all, and created these test cases, it was much easier for me to go in and do what we needed to do. And that is why I like Exorcism so much. The tough problems that they have on there, when you get up to the harder levels, those tests are phenomenal. Some of them you have to write your own, and they don't give you a lot, but they do help you out a ton. All right, yeah, it is, Teo. It is absolutely similar to HackerRank, just less competitive. It's just, just coding challenges. And like I said, it's one of the, I like this one in particular because HackerRank and all the other ones, you do them on the website themselves. And I like this makes you interact with your own computer, your own workspace, which I think is good for beginners. I know some people are like, oh, that's not good. I think it's great for people starting out to get comfortable running things, understanding their computer, understanding the command line, understanding how to submit this stuff from the command line, how to, open up a new file and compare files and stuff like that. So that's my ethos. If you hate it, you can do these things wherever you like to do them, to be 100% honest. But yeah, it is like HackerRank. I do like HackerRank. I want to start doing some more HackerRank stuff because I'm trying to be a boss. I'm trying to get good, real good at software. Because if I can be really good at infrastructure and really, really good at software as well, then I can build something that might change the world one day. I'll be honest with you all. I always have wanted to have my own product software company, just because it just seems cool. It just seems like a cool thing to I built this thing, I built this really cool thing, and now people pay me for it. I think that would be exciting, but yeah, it's fun. Okay, so maybe we can all, I'm telling you, maybe, as this stuff goes on, maybe we can, maybe we'll stumble onto an amazing project and we all can start building it together. And, we'll be the interesting group of 50 people who took over the world off of, a spark that we got online. It'll be pretty exciting. V3 wants people to enable programming in the browser. The thing is that I definitely get what they want, where they want to go with Exorcism V3. I 100% understand. I 100% understand that, and I think now it's a little more feasible for that to happen, especially with things like GitHub workspaces coming out and all that stuff. Programming in the browser is going to be the thing. There's going to be a time when it's the thing, but even when you're programming in the browser, you're still going to have to interact again with for a while. You're still going to have to understand. People are still going to have to understand how to, interact with the command line, understand the difference between their files and stuff. But I do agree that that's how you get people to use your stuff, and minimizing obstacles I do think is great. I just think there are so many things already out there that have minimized the obstacles. It's interesting and refreshing to see one that still makes you jump through some hoops to kind of get some stuff done. Okay, that's all the slides. And why is that all the slides? Because we're gonna hop right in to Exorcism and we're gonna have a little bit of fun. So, did I have Exorcism on here? I'm pretty sure we were already at Exorcism before I stopped using this, but we're gonna find out real fast. And we're gonna take a look at some things we've already done if that is the case. Ooh, no. Okay, maybe I put it in a different place. You know what I did? Nope, I'll set it up real quick. If you don't have Exorcism set up, feel free to do it, but it's also not super essential. What I'll do is any of these problems I'll push up before we start on them. I'll push them up to GitHub so that you can pull them straight down from GitHub, so that it'll be nice to have the files right there with you. Let's do we're gonna do Python, but okay, real quick, we're gonna do Python, but we're gonna just jump into Go a little bit, because Go, I think, will surprisingly, because of something called structs in Go and the way that they set those up, it might, we'll see. It might be a simpler concept to kind of take a look at those. We'll do both. We'll do both really quick. Let me just set up Hello World, because Hello World is an interesting one here as well. And let's actually, let me download this. I don't want to download my solution. I want to just download whatever. Ah, yes, I don't have exorcism here. So let me, come on, teach me what to do. I have to click on one that I didn't do yet. Not Twofer, Matrix. Oh, I didn't turn it into Twofer. Perfect. Begin walkthrough. Let's, I want to do it so bad. It feels wrong, but I'm going to do it anyway. YOLO. So Snap, I think I talked about it before. Snap is simply a, it's an interesting package manager for Linux. Just kind of following this like containerization, like you know, isolation paradigm. You know, some people hate it. I definitely don't love it. I definitely don't love it. I installed it, so if I do exorcism, I should have just did a reset, but I did not. Yeah, there we go. All right, so exorcism is installed. Let's go back, configure the CLI real quick, and you all can probably steal my stuff, but that's fine. If you want to do all the answers for me, feel free to do all the answers for me. Okay, so let me clear this, and let's do download. All right, so I'm gonna download the Hello World one again. And I'm gonna go to, oh, look, see, this is why people don't like Snap. It put it in a weird place. That's gonna bother me a lot, actually. Okay, all good. We'll just go there now. We'll do what we gotta do to get through today. All right, I'm gonna start out using VS Code for you all, so we can see so we can view things a little bit easier. We'll have a little more control over the view itself. What I'm gonna do is I'm gonna open up the Hello World file that they gave us with our solution. And this is what they gave us before we actually implemented a solution. They gave us this as the subcode, and then this is the test file here. Now, first, let's talk about some of these tools a little bit. Every language is going to have a different testing suite, tools or paradigms that exist to help you test your code. They all have a bunch of them. There are, so this is using unit tests from PyTest, I believe. It's a module in PyTest, I believe. PyTest is one as well. You got to look into whatever framework you're using to be able to figure out what you need. JavaScript has all kinds of things. If you're doing React and stuff, you can use Jest, there's Mocha, and there's Chai, and there's all these different things for you to use. There's different frameworks, different packages for unit testing. There are some more universal tools for integration testing. And you can actually do some integration testing with these tools as well, but they're designed for unit tests. There are some great tools out there like Selenium, which is great, which is pretty good. There's a lot of other things as well. A bunch of tools. We'll go over some of those a little bit later for integration testing and that kind of external tools you can use to automate some of those tasks. But each language is going to have a different framework for this, and in knowing that, it also means that the syntax, the implementation of things is going to be a bit different as you touch each of them. So it can be a little bit confusing. So the goal of today is, again, the concepts is to understand what these unit tests are doing. And I think you'll be able to, as we touch this and as we dive over to Go, maybe we'll jump over to JavaScript as well. I think you'll start to understand how these unit tests, how to think about these unit tests so that you can implement them in the future. Eliminated space, absolutely. We'll definitely be doing some Go. Sure. Yes, you do need the API token for the CLI. They give it to you though. Yeah, I can also change my workspace. There's a workspace option to do that. PyTest is really great, but unit test is from the standard library. Yeah. If you want more Go algorithms, you can check out Algorithms in Go class by John Calhoun. I will absolutely check that out. Like I said, Go is my favorite, and here's the thing. Right now, I'm learning a little bit of Rust, but I think the language that I want to focus on the most, again, to really understand the concepts very deeply. I want to mostly focus on the language. And I think I'm going to pick out Go for that. I do think I want to go down that road, but I'm just holding on a little bit to just, make sure it's the right choice. I'm trying to make sure that, my fanboyism of Go isn't clouding my brain, and maybe I shouldn't go with something else, but shouldn't go with something else. But I'll definitely check that out. That sounds pretty cool. Okay, so we're going to be, let's take a look at this and let's kind of break down what's here a little bit. So one, you see the word class in here, so you should automatically first be thinking about, thinking back to what we learned with object-oriented programming and how this is kind of working. But that is not an incredibly big part of what we're doing. I just want you to start to pick out the things that are in here, because I know when you first jump into code, it can be very confusing. So, a lot of stuff you haven't seen, or like, there's just stuff in here. But it's things that we've seen before. So we have this class called Hello World Test. But first, we're importing this unit test library. And then we're also doing this from Hello World import hello. And so this line, we talked about imports a little bit, but what it's doing is it's saying from Hello World. And this is a paradigm that exists in Python. It exists in other languages as well in different ways, but it's basically, because this is in the same directory, it's basically saying we have this file here called hello world.py. When we say from hello world without the py here, Python understands, it says, hey, I'm going to look in this directory here, and I'm going to be looking for this file, this package called hello world. And from that file, it's going to import hello. Okay, and so let's actually put these side by side. And this is the code that we're going to be writing, and this is what we're going to be doing. And so what this is the test file over here. And what it's doing here is it is importing this function into the test. So it's basically taking a function from one file and it's allowing us to use it in another file. So if we were to write another function in here called def goodbye, and and we're gonna have a goodbye message in here, to be able to use this function in another file that is in this directory or in our project, we'd have to do this from the same file. So this is the exact same file called hello world.py. So from hello world import goodbye. But we could also, I think, do this in the same line. I think I could import a couple different things. I think I could do like import goodbye. Pretty sure I could do this as well. But I do have to import that thing to get it to be used in this project. I might have to put that in some quotes or something. Again, I never remember syntax ever. But yeah, so from hello world import hello, and that is what we're doing. So it's allowing this test to use this hello function that's over here. And that's kind of how most of these are going to be set up. It's going to be a little file that's going to be importing some of the things that are over here. So this starts to tell you a couple of things when you start to look through here. It starts to tell you can see what it's importing, and you can see how it's using it. So it starts to tell you where you need to put code and what you need to do. So it's going to set up this class for hello world, the unit tests and test cases. And so it's going to list the test cases under here. And most of the testing paradigms are going to be a set of what are called assertions. And assertions are going to be scenarios that or statements that you are saying they need to be true. So there are more than just this assert equal. There's a couple of these. Let's see if it gives us what other things. And so you have some options here. Look, assert almost equals, almost equals, count equal, dict equals. So there's a false, assert greater. And so all these have different paradigms. So the one that we are going to be using is that assert equal. And that's going to say, hey, I want you these two things I'm going to pass to you. I need you to check and ensure that they are equivalent. And that is what we're doing in this little function here. So this is just a little function. We're testing say hi, and check out what it's taking in as a parameter of the function. It's taking in the hello function. So it's basically saying, hey, run this hello function with no inputs basically. And what I expect, basically it's going to assert that when I run this task, when I do the first thing that I pass in, I'm expecting to get this as output. And so that is how you want to take a look at it. And then you a lot of them are going to be set up like this. The basic tests, they get much more complex than this, but you know, right up front, you can really start to get some really great tests in by doing exactly this paradigm, by saying, hey, let me run this function with some so this one doesn't have any input, but we could pass in some input. I could say, you know, if it was supposed to take input, I could, you know, check to see what happens when I pass an input or something like that. But we're going to run it, and this is the expected output. And so if we run these tests against our code, if the expected output that's received is not that, then it will fail. Yeah, then it'll fail, and if it matches that, it'll pass. Now, these unit tests, they do give you some good information about this, but it doesn't really mean that the application is working how you want it to work. But you know, so that's why you have to be thoughtful about these things, and it's very difficult sometimes to think of different scenarios that would cover all the cases that you need. But we're going to practice doing that tonight as well. But that is why when people first do this, when I first got on Exorcism, I had an issue with this. I was trying to figure out what was wrong with this piece of code. What was wrong with, like, I did it. I was like, oh, cool. I'll hop in, I'll print. They want me to print hello world, so I'll go ahead. I said, I'll print hello world just like this. And I said, great, go ahead and print that hello world. And I saved it. And, you know, I wasn't familiar with test-driven development. I was like, this one's super easy. Oh, thanks. I was like, appreciate it. This one's super easy, no big deal. You know, I'll knock out this one so I can move to the next one. But if I go ahead and I run this, if I run PyTest, oh, did I not have PyTest? That's gonna suck. I thought we've run PyTest before. Is it Python dash Python? Let me see. pip3. Oh, this is gonna be a problem, isn't it? This is gonna be a problem. And so they do tell you how to run the test in the README. There's a README in here that has all the information that's on Exorcism, and it does tell you at the bottom how to run PyTest. So run PyTest hello world test.py. But you may need to install it first. The way that I did it, I said pip3 install PyTest. There we go. So that's how you can do that. It should pass though, since the function it says pass. Yep. So no, yes, no, second billing cycle. Yeah, it says pass. That's just to keep it going. That would be nice if it said pass. But those will be failing tests. And so actually that's what we're trying to do first. So let's put it back to how it was. And let's put a pass here, and let's just run the test as is. And so the way you run the test is I'll type in PyTest. Oh. Whoops, reset. Really? Python 3 PyTest? I know it's not sudo PyTest. That would be whack. Let's see, source CSH. I could source it, but I don't think it's installed there. Let me. I don't think that's gonna do it. Oops, I didn't mean to do that. I wonder if it's. I wonder if I have to call it at which Python. User bin. No. Let me see here. We'll get it working in a second. Is it Py? Interesting. Hold on, we'll set that up. Oh, will that work? That would be cool. Yeah, it's probably from the bin, and I can see where the binary is, where the bin directory is of that. I'll check that. Oh, interesting. Python 3 test file.py. I didn't know that. If I can do that. Interesting. Yes, PyTest is cooler than this. That's very interesting. Let me see something real quick. Pip3 install PyTest. I just want to see something real quick. And this is one reason why I kind of dislike Python sometimes. But like if I do sudo pytest now, watch it be available. Yep, if I do it now, it is available. Python's, I need to fix my binaries and stuff, but it's all good. What's up, Mary Jo Stabler? Welcome to the channel. Thank you so much for the relatively early raid. This is great. You're hopping in right on time. We're on the basics of what we're doing. Kind of the first example. You know, we just fought through a little bit of PyTest issues, mostly pathing issues, pathing and binary issues. No big deal. We'll knock those out. I kind of want to stay focused on just getting it running, and it is running right now. So welcome to the channel. Thank you everyone from Mary Jo's channel. Shout out to Mary Jo. Thank you so much. How was your stream? What were you all doing over on Mary Jo's channel today? But thank you for the raid. Good to have you. Great to have you. Oh, what's up, Jitter Ted? How are you doing? I didn't see you come in here. How you doing today on this fine, lovely evening? First off, it's supposed to here in Baltimore, Maryland, it's supposed to storm for like a week and a half. It's supposed to thunderstorm all day today. It was kind of gross last night, rained really hard, but today actually turned out to be a beautiful day. It's pretty humid, you know, because after the rain, lots of heat, gets humid, it gets really humid, but it's supposed to rain every day. I'm hoping every other day will end up being just like this. Let me show y'all. Let me see if it'll look how disgusting these next couple days are. My camera's not on autofocus, but that's a lot of stormy showers for the next couple days, which is very unexciting. Very unexciting. That's not getting the way back. That's awesome. Well, I'm glad you're here. Make my day brighter since it's so gross. Since it's gonna be gross. Is it still nice? Yeah, no, still beautiful outside. But we don't like to see the sun. We gotta close all the curtains, you know. We gotta be homebodies in here, you know, mostly for effect. But we got PyTest running, and check this out. We all know that green is good and red is bad. You know, red means stop, means something's wrong. We also know that Fs are probably not very good. So that F means failure. We have one test here, which is this test right here, and it is currently failing. And if you take a look at it, it tells you exactly what happened. And we saw this before. I think we did this when we first got into exorcism, but it says, hey, assertion error. This first option is going to be the value that it received back when it ran hello. So it says, hey, none is not equal to hello world. And we saw that hello world was the expected output over here. So it says, hey, none is not equal to hello world. This is a failing test. One test failed, and this is how long it took to fail. So that's when it says pass. So you say, okay, you know, let me go ahead and let's do what I thought I was supposed to do. And this is what a lot of people do. If you Google, there's so many people who are like, hey, exorcism's number one, the first hello world problem, I can't get past it. I don't understand. I know how to write hello world, but I cannot get past this first one. It is, you know, why is it wrong? And so maybe most people are doing this. Most people are printing out hello world, because when you learn how to do hello world, this is usually the first thing that you do. So you go in and you do that, and you go ahead and you run PyTest again. Whoops. PyTest, I'm supposed to do sudo PyTest and the name of the file. And we run it, and once again it says none is not equal to hello world. And you might say, what in the world? Like, you know, it's actually printing out hello world here. It captures the standard output call. It's actually running, and if you run this file, it prints out hello world, and you're like, what is happening? Why isn't it working? Why is it getting none? We learned about scoping, we learned about functions, and we learned that the things that happen in functions are isolated to the scope of the function, but to get information out of that function, to use information outside of the function, you have to do what? You have to return that value. So instead of printing hello world, we're gonna go ahead and we're gonna return hello world instead, because this is a function. You gotta get this information out of that function. So let's do it again, and we say, all right, we figured it out. We think we're good to go. And oh no, it's not right. And we're like, what? It says run hello world. I ran hello world. And when you take a look at it, you can see, hey, my assertion is yes, you did say hello world, but that is not equal to hello world. And you might look at it, you might say, what's going on? And luckily they give you a little information down below. and it says, all right, hello world, almost there, but look at this line here has an extra little plus here. It's there's a plus underneath the comma, and you're gonna say, oh no, like you need it to be exactly that. Yes, computers aren't gonna try to guess for you what you meant. It says, hey, you said it was gonna be this, let's make it exactly this. And if we run it again, we got all greens. Excellent. And we could have seen that. We could have known what we need to put there by again, looking at the test that was written, looking at the test that ideally in the future, we are going to be writing. And we could have said, all right, it's supposed to be hello world. And I could have copied and pasted this value instead of just doing whatever it is that I wanted to do. And that satisfies the one test that we have. And again, we could extend this. Maybe I also wanted a function that said goodbye. So maybe let's practice a little bit of that test-driven development. So let's extend this and say, all right, this hello world file is now going to have a goodbye. And again, we can go down and we can say, all right, let's write a function let's write a test that's called test, say goodbye. And really, you don't need to know a lot. Just start to look at the patterns that you see in front of you, and you say, all right, I'm going to copy everything that's here. I'm just going to copy it because I know that this thing tests an input and an output. And then, so I'm just going to copy it, and I'm going to say assert equal. Make sure these things are equal. I'm going to run not hello, but because I'm not going to use the hello function, I'm going to assume there's a goodbye function, and I'm going to assume that function is called goodbye. I'm gonna say, hey, when you run that goodbye function, I want it to say goodbye, exclamation point. And so that is how you would write the test, knowing that the functionality that is requested out of this application is to create something that says goodbye when called. And so this is how you could extend this to try to do that. And now if we save it and we run these tests, we should now have a failing test. And look at this. There's an F here for the failure, but there's also a dot. It's a green dot for passing. So that's good. The dots are for passing, good little visual representation, but there is one that's failing. And it says, look at this, name, error, goodbye is not defined. So we've done the first part of TDD. We've written a test for functionality that we want to create, it's a failing test. And now we need to write code to resolve this, to make this test now passed. So we're gonna use this to guide us. And we're gonna say, all right, we need to, again, import, I'm gonna put import star. I think I can do this. I think I can import literally everything from this file. No, let's be explicit. Can you do it like this? I have no idea if you can do it like this in Python. It is red. Oh, that's a breakpoint. Why is there a breakpoint here? Interesting. So I'm gonna try to import both things, hello and goodbye. And let's go ahead and write our stuff here. Def goodbye. And we need to return exactly what we need to return. So let's copy and paste. Say, hey, we know what it's expecting as output. So let's actually return the actual output. Let's actually return the actual output that we want here. So we'll save this and let's go ahead and try to run it again. And if we test it again, now we have two properly passing tests. So it's testing again, right now we're testing very basic functionality, but we are testing some the functionality of our code. And again, it gets way more in depth than this, but when we're going to practice, we're going to get more in depth shortly. Does anyone have any questions so far about what we've done? Is it a function if it doesn't return anything? It is a function if it doesn't return anything. It's a function, but it's more of a little job or process. But it's a function. Yeah, you do. You got to celebrate every passing test. That's what the green is for. You gotta, we need a yay button for when we do something good. What's up, David Snyder? Are you for the Redskins? But what's up, David Snyder? Welcome to the channel. Thank you for the host. I can do it like that. Perfect. That's good syntax. I don't mind TD, but I think I write code better without it, to be honest. It's a good framework. Eliminate space. Yes. And that is one thing. Again, I think TDD usually gets pushed as like this end all be all. Like this is the way, like this is the truth and the light. And again, there's already been studies that says, hey, this is not necessarily better. It's not going to make your code more bug free. But again, there's different methodologies that it may in your case, it may in someone's case. It all depends on the way that your mind thinks. It takes time to be able to do this properly. Again, it's very difficult to be able to think about those edge cases, to be able to think about those things beforehand. And you may spend more time trying to get full test coverage than developing the actual feature, which can be problematic. But again, it's a paradigm that we should be familiar with. We should understand it so that we can make the decision while we're developing to determine if this is the way that we want to do something. I do think it's something cool to practice every now and then, keep your skills sharp, because I do think it can be valuable, especially for problems you may not, where you have a good understanding of of what the solution needs, but not necessarily know all the implementation. I would suggest trying this out a little bit and then coding to it. Do your best, try it out, have a little bit of fun. What happens if you forget to import goodbye in the test? It simply won't have access to the goodbye function. So if I do not import this goodbye function, when it tries to run this, it'll say, hey, I don't know what this is. Goodbye is basically undefined. It's not a thing that I know about, so I can't really do anything. So if I try to do this here, we will get this same error that we got before, which says name. Goodbye is not even defined. So you need to make sure that this test file has access to whatever functions that it needs from your main file. All right, let's see. You can have multiple return statements, or does that break the code? You can return multiple values. You can, so only one return statement will ever run. You can have multiple return statements. Like I said, only one will run. You can only have multiple return statements if one, you can have multiple one. Well, in an interpreted language, you can have more than one. Even in a statically typed, a compiled language, you can as well. But the return needs to basically be inside of a conditional so that it may or may not run. And so you can have more than one return. I generally try to stay away from that. And we're gonna get actually the next example that we're gonna do is going to show whether or not we can have that. If you want to return multiple things, you can return multiple things with a comma. I can return, hello, goodbye. And now this is going to fail because I returned two values. You can return multiple things from a function. Whoops. How do I do this? There we go. And if I run this now, see, I got hello, goodbye, hello world, and goodbye as a result from the hello function. So you can return multiple things. That's how you would do it if you want to return multiple values with a comma in between. But yes, multiple return statements, not really a thing. Yes, I will get you a link to the studies, to the articles about it. There are a bunch of them now. Used to be pretty sparse, but there are a bunch of them now. I've developed an allergy to the way I feel you. Haven't really provided either way for TDD. Yeah, that's dope. Oh, that's pretty cool. That's very exciting, actually, that you have your own, you actually have an article about this. Yeah, like I said, the stuff that I found hasn't really claimed that TDD is better or worse. It just, it's a methodology like anything else. It can work for some people. I'm 100% sure there are some people and projects where this has been super effective, and if they had done it another way, it may not have been, it wouldn't have been as good. But the data so far is not proving anything conclusive. Yeah, everyone should check out that article. It's really good. Also, I know some people, as you're trying to learn this stuff, some of the articles may seem a little over your head or something. I'm telling you, read. When you come across things like this that are pertinent to what you're doing, definitely take a look. Definitely, I'm actually going to add that to the Google Classroom right now for people to actually read, because this stuff is, I can't tell you how much it will help. Like, stuff like this is really also what will help you get, it's really going to be really good at interviews, to give you some context around things, to have discussions, have bigger, deeper discussions. I highly encourage you checking out things like this. I used to ignore every single article and stuff. I was like, I'm not reading that. I don't understand what it's talking about. I'm telling you, read through it. The context will start to become important, and it'll give you some talking points. It'll give you a frame of reference to talk about things in. I'm gonna say Ted's sweet. Actually, no, we need to do some alliteration here. Ted's terrific. I spelled that wrong. I'll fix that. TDD. We need one more word. TDD. TD. Okay, I can't think of anything. Ted's TDD. What's another word for topic discovery? There. Well, then I was topic talk. Cool. We're gonna do that, and then it's gonna work. It's fine. It's gonna work for this. Having a little fun with the way that we do this. I'll definitely check that out as well, Ted. Appreciate the share there. Go back up. Get back to the chat. Testapalooza. I did not have the chat up. So yes, Testapalooza is absolutely what we're gonna change this to. TDD Testa is a testo palooza. There we go. We'll save that. I think writing testable code is a real value of tests. Yes. Pot liquor. That is 1,000. I love that. Writing testable code is key. Whether or not your tests are amazing up front, I don't think really matters, but writing testable code, man, I used to not care about, again, as someone who didn't come from a software background, I used to didn't care about it until, I started to dive into this world a little more. We had the project that I work on, we used to have the most passionate test engineer. I'm very confident that no one has ever met anyone more passionate about testing than him. I'm definitely gonna try to get him on here one day to give an overview of, different testing paradigms. I've learned so much from him, and writing testable code is extremely important to me now. And like just testing as a whole, like my understanding of testing now is much bigger than it used to be, and like it can done well. I won't even say done right. Done well, it can save you so much time and energy. And what it does, as someone who is in charge of applications and the infrastructure and the upkeep and the maintenance, the amount of just confidence I have in the application and things because of the testing, the amount of testing that goes into it, the amount of automated tests that we have that are quality tests. It's not about the amount, it's about what they're actually testing. It makes my life so much easier, like so much easier. The major refactor on stream, and the test made me super confident that it didn't break anything. That's awesome. That is so that's excellent. A lot of times, yes, if your tests are done, I mean, sometimes they need to change. Sometimes there are refactors where your tests absolutely need to change, depending on what you were going through. Your integration test probably should need to change for a refactor. Unit tests might need to change sometimes depending on how much you're going to do, but absolutely, that's pretty awesome. That is that makes you feel really good. What's up, Paul Blart? What's up, gamers? Hey, that's me. I am gamer now. How would you do tests for IAC using Terraform? Ooh, this is good. That is a very interesting topic. We have internal discussions about this in our company right now because it's something that we're trying to figure out. It is very difficult. The paradigm of properly testing infrastructure it's a different ball game. It's a much different ball game, and so the workflow for that is super weird. I don't have a good answer for you. I really don't have a good answer for you. I mean, you could. Some people have approached it by deploying entire canary infrastructures to test against, and having basically integration tests that test from the actual infrastructure. It's expensive, it's heavy, it's time consuming, There's a couple different ways to approach it. I don't think there's any great ways to approach it right now. But I think that's something we should talk about a little bit. I try to ask that again a little bit later. I can show you some of the stuff that we've gone into and that we've tried. And some of the things that I think are helpful and the things that I think people are doing that are not helpful. I think there's a lot that people are doing just to say they're testing something. But again, I think tests should provide real value. Like, we're not writing tests for the sake of writing tests. I mean, some people do, a lot of people do, because it's part of the job requirement, but I don't subscribe to that. I think it's a waste of time. Like, your tests can and should provide value. So I think that the jury's still out on how to do that properly. Oh, but it's a phenomenal question. That is exactly how I want you all to be thinking. That's really good. 100%. Okay, so let's hop into one that's a little more interesting. And I came across this the other day when I was actually trying to do some of the Rust problems, because I was trying to do some of the problems that I've already done before in other languages while I was trying to learn Rust. But let's head over to Exorcism here. And there's an interesting one here because a lot of them are like this, but just I think this is a relatively new one. I hadn't seen this before. It's not particularly a difficult one, but there's some interesting caveats when it comes to the test, and maybe not caveats, but things that there are things that they do not talk about inside of the README or inside of this introduction. They do talk about that they test for in the test cases. So you got to be, got to be good about that. But this problem here, it says, hey, determine if a triangle is an equilateral triangle, an isosceles triangle, or a scalene triangle. So we're taking you back to middle school, high school geometry class, wherever you had it. We're going to determine which kind of triangle something is based on the length of sides that are passed in. So it tells you what they are. An equilateral triangle has all three sides that are the same length. All three sides equilateral triangle. So that, it makes a little bit of sense. An isosceles triangle has at least two sides that are the same length. So, two sides that are the same length. It is sometimes specified as having exactly two sides of the same length, but for the purpose of this exercise, we'll say at least two. I don't know why they are saying that. I don't know why they're caveating that. And maybe the test will tell us that, because three sides of the same length, at least two sides. Triangle only has three sides, and isosceles says at least two sides have the same length. If the third side was the same length, then it would be an equilateral, but we'll talk about that in a second as well. And then scalene triangle is when all sides have different lengths. Great. So they give us the three scenarios, what they mean, and it sounds like we're going to have to write some code to determine if a triangle is any of these things. And so they give you some more information, but let's go ahead and let's download this and let's start taking a look at the code. And yeah, we'll do it in Python. It's fine. That doesn't really matter. All right, so I'm gonna head over to triangle and I'm gonna open it back up in VS Code. Hurts me to do so, but I'm gonna do that for you. What time is it? How are we doing on time? 8:12, perfect. We're right on time. Ooh, what did Bobby Boucher say? Man, that's some high quality H2O. That was good. It had just enough time to get freezing cold in this double walled insulated bottle. Man, that was incredibly refreshing after that cup of coffee. That woke me up a little bit too. That was nice. Let's take a look at the README. The README has everything that we need in here. Who's that? Larry and Y. First off, welcome to the channel. Thank you for the follow. I feel like you already followed, maybe not. What's up, Steak? What's up, ACD Games? Welcome to the channel. Thank you so much for the follow. Popping that G Fuel. Hey, I wish there was some G Fuel in here, to be 100% honest. That would be fun. I'm trying to stay away from the, I'm trying to stay away from all the energy stuff. Keeping it clean. Big fat finger at some point. All good, all good. Well, welcome back. Welcome back to to the follow. But yeah, so we have the README here, and we can go through and read and get all the information that we need. So we need to determine if a triangle is equilateral, isosceles, or scalene. We're not worried about that right now. We're not worried about how to do it yet at all. We're just reading about it. We don't want to be thinking about implementation yet. Note, For a shape to be a triangle at all sides must, oh, maybe, you know what? This test case, I didn't see this. I saw this test case, but I didn't read the whole thing. So it actually is in the README. But it says for a shape to be a triangle at all sides have to be of length greater than 0. And the sum of the length of any two sides must be greater than or equal to the length of the third side. So that's, you know, that's an interesting a little thing in there. No problem. But that gives us, you know, that note it doesn't tell us directly, but that note kind of says, hey, I might need you to account for these things. But it doesn't say anywhere in here like, hey, go ahead and make sure that you have made this work properly, including the note. It's just in there. Dig deeper. The case where the sum of the length of two sides equals that of the third is known as a degenerate triangle. I don't know anything, but that's a new one to me. I've never heard of this. You know, I heard about these in geometry class, but never about this. So we're learning something new. It has 0 area and looks like a single line. Feel free to add your own code test to check for degenerate triangles. That is that's exciting. That's very exciting here. Interesting. And then this part and below, whenever you get to the exception messages, this part and below is the same on every single one. It's just letting you know that, hey, there are times when you need to raise an error or an exception. We haven't got there yet. We're gonna be talking about that on Monday. And that you might need to do that in certain cases. And then this just tells you how to run the test. So yeah, A plus B equals C is a weird triangle. That's what it sounds like. That's why they call it a degenerate, because it is, you know, it's a weird triangle right there. It looks like a line, 0 area underneath. Very, very interesting. Very, very interesting. So here's what we will do. Let's take a look at the code that they gave us, the stub code. They usually give us some stub code. Let's take a look at that stub code and look at that. The stub code. Let's move let's open up both of these. We'll open this up over here. Stub code is over here on the left, and the tests are over here on the right. And so we've got 3 functions right here. We have equilateral, we have isosceles, and we have scalene. So they give us some functions, and we're just going to assume we can kind of read that, and we can start to make some assumptions about, hey, this is going to be a function that checks if a triangle is equilateral. This is going to be a function that checks if it's isosceles. This is one that detects if it is scalene. So super exciting. And then here are the tests. Take a look at the tests, and it's important to read the test names. So here's a class here for equilateral triangle test. This is where we're going to be checking for equilateral triangles, or at least that's what we named it. And all this is the same as before. So this is just the way that you write these tests, and then just start to take a look at it. So the first test, they give it a name, test that all sides are equal. And so this is the test case. And so the numbers that are inserted here are simply to test this case. So when we want to determine if something is equilateral, basically the coverage that's here is basically all the different scenarios that could happen when a triangle is passed in, and we need to check against those things. So first one is checking what happens when all sides are equal, and to do that, they're passing in a list of the 3 different sides. So they're passing in a length of 2, and a length of 2. That's where all sides are equal, and they're expecting to receive a true back. And that's what they're expecting to get back. This is what they're going to pass in. They're going to call the equilateral function. So we have an equilateral function over here. We're importing it up here, and we're going to be expecting true. And then we're going to have a different test case, a different scenario where test any side is unequal. So 1 unequal side, and you can see here 2 are the same and 1 is unequal, and we're expecting false back, because again, equilateral triangles only are equilateral when all sides are exactly the same length. And so we got a couple here, but we also have one here, test that all 0 sides is not a triangle at all, basically. And so that was a part of the note here, basically that it's not actually a triangle if the sides aren't greater than 0. So if you were to pass in this, it might look like it's an equilateral triangle, but it's false. So These are the things that are important. These are the test cases that are hard to find. These are those edge cases that sometimes it's hard to think about, because if we were to just take on, you know, what an equilateral triangle is, and we were to write some code around it, it would probably return true by, like, you know, if we don't handle that test case. The code to determine what an equilateral triangle is would probably return this as true. So we need to put in something to handle that and to make sure that's, you know, the case. And you know, test size maybe floats, you know, floats instead of integers. That's fine. And these are all the same, and that's true. So just a couple different scenarios that we're going to be going over. And so we can use this information, and we can code to start to make sure these things are true. And you can run down the line, actually. And so sometimes it's good to look at all of them, but you can actually, you know, hey, I want to write some code just to make this one pass. I only want to make this first one pass. And that's all I care about to start. And then I can go down and, you know, the ones that are failing, I can modify my code. I can iterate over my solution to make more and more test cases pass. And eventually the idea is that you will eventually get to where you need to be, and your code will actually solve the problem that you want to solve. So let's go ahead and let's start writing some code. And like I said, I started to do this one, but then I just didn't do it because I was doing, the problem was I was gonna do it, but I went down to Rust. I went down a whole Rust, like I Googled one thing about Rust to kind of find something out, and I went down a whole little paradigm. I started playing around with other stuff. So I've actually never even done this. It's interesting though, because the immediate way that comes to mind for me, I'm not gonna talk about it yet, has nothing to do with actually testing the sides. And I don't know if it would be valuable at all, but we'll try, maybe. And it would only work with Python. Or only work as easily with Python, but we'll see. We'll try some stuff out. So let's start to do this one here. So all we want to do is we want to make this first test case pass. So we want it to basically, if all sides are equal, we want to, you know, we want it to return true. So you might say something, you might do something like this. If you were first diving into this, you would look at it and you would say, all right, I need to compare each of these things in this list. And you know, there's a lot of ways to start to do this. And you might say something like, all right, sides is going to get passed in, so this collection is going to get passed in. And you might say, let's say if the first item in sides is equal to sides 1, and we learned about this before. Actually, Python is just and. So let's actually scroll over a little, let's close this a little bit. And sides 0 is equal to sides 3 or 2. Then go ahead and return true. So, whoops. What am I doing here? What did I just do? Right here, you know, and again, we're not doing the best way first. We're going through what we know, and this is a very reasonable way to go about this. And we say, hey, if sides 0, so the first item that comes through in the sides list, which is going to be 2, we're going to say, hey, if that's equal to the first to the second item, so if this one is equal to this one, and this first one is equal to the third one, so and this one's equal to this one, we can automatically assume that this one is equal to this one. Or we could be explicit about it. You know, it's okay to be explicit about it, but then we would return true. And then we could say else, whoops, I spelled return wrong. And then we could say else, return false. But we learned last time that you actually don't need, because return ends this, you don't need an else. You can simply just return false. And let's spell return properly. Okay, so we're gonna check first to see if side 0 and sides 1 are equal, and we're gonna check if side 0 and sides 2 are equal, and then we can assume that that means sides 2 and 1 are equal as well. And if that's the case, we're going to return true. Else, we're going to return false for this one, and we're not going to be explicit about the third case. And so we're just practicing some of those things. Remember, when you get into equality operators, when you use this AND operator here, that means this on the left has to evaluate to true, and this on the right has to evaluate to true to run this piece of code right here. So they both have to be true for this to happen. And so we can save this, and now we can run our tests to see what happens, to see if we get this thing to pass. And we're gonna run sudo pytest triangle test.py whack. Okay, and look at that. It says, hey, 15 failed, 4 passed. So we actually got 4, correct, but it doesn't mean that they're correct. But it means that there are 4 that are passing. And how do you know which ones are passing? We're actually going to go through and we're going to comment out some things so we know. So it looks like the first test is passing, the second one's failing, and the rest are passing. So it tells you which one. It does go through them in order. And so it says, hey, this second one here, when zeros are passed in, or wherever it is on the list, it says true, not false. But the one that we care about is passing. The one that we care about is in fact passing. But what we can do real quick to make sure that we so that we can ignore some of these other ones, so there isn't as much output while we're trying to learn how to do this properly. I'm gonna go from line 25. I'm gonna highlight line 25 all the way down to line 68, and I'm gonna hit Control /. And what it's going to do is it's going to comment out all of that code. And so if I comment it all out, none of this code is going to run. So I only want us to focus on these tests right here. There are other ways not to get those tests to run. Don't sweat it right now. We can skip those tests. We're just kind of cleaning up a little bit so that we can not get as much output, so we can try this again. So I'm going to clear this away, and I'm going to run this just so it runs a couple tests. So in this suite of tests that it runs here, how many tests are here? There are 1, 2, 3, 4, 5 tests right here. And it runs through those, and we only have one with the code that we've already written. We only have 1 failing test. Now, I would be careful in cases like this, where the expectation, the output is a true or false value. When that's the case, I mean, you're going to get a lot of tests that you get right because of luck. So we need to be cognizant of that when there's only true false value. So 4 of them pass. The only one that did not pass was this one right here. Test all 0 sides when it's not a triangle. And so we can see here, self that asserts for the one where it checks all 0, it came back as true. And why did it come back as true? Because all of those sides are equal, but a length of 0 does not equal a triangle. For it to be a triangle, all sides have to be greater than 1. So now we know that our code is checking for something. It's kind of working, but we know that we have to now iterate to be able to make sure that it can filter out things with a 0 value. And so we only have to make 1 more test pass, at least for this piece. And so there's some things we can do. There's a lot of ways we can handle this. We are going to change this code. We're not going to leave it as is, but we're going to change this code up a little bit, but not right now. We need to iterate on that. So basically, we need to check if it says all of the sides have to be greater than 0. It can't have any sides that are 0. That is what is listed in the note here. For a shape to be a triangle at all sides have to be of length greater than 0. So what we can do is we can check, we can do something like this. We can say, hey, if 0, can we do this in sides? So like Python gives you all kinds of fancy stuff. Sometimes I don't love this because this is why I like Go a lot. You have to be pretty explicit, but I think you can do something like this. I think you can use the if-in statement. So I can basically say, hey, if there's a 0 in the list in the sides list, then you can go ahead right now and you can return false. And so this might work. I don't know if it's gonna work. We're gonna try this out real quick. Let's see what happens. And it does work. And all 5 tests pass. And so what this does is this says, hey, I'm gonna iterate. Basically, this is like a for loop. It's like a for in loop, for each loop. It's basically gonna go through sides. It's gonna say, hey, if this value is anywhere in this thing, do this thing. Now, I don't like, one thing I'm gonna change up on here before we refactor everything. I don't really like this. I don't really like having this many return statements. It's fine. You are absolutely able to do this. Me personally, I don't love it. Some people don't mind it at all. What I would rather do is I would say, I would set a variable up like, is equilateral. And by default, I might set that equal to false or something, or just set it up as an empty variable. Well, I think you have to give it a value. And I would set it to false. And then here, I would, instead of returning false, I would set is equilateral. I mean, so it does save you, it can save you some time in a larger application. It all depends on that. But for a small application like this, I like to be a little more, I like to be a little more explicit. And I don't like that so many return statements. And so I'll set it equal to false here, or I'll set it to true here. And again, this is a matter of both preference and situation. And instead of returning false here, I'll return no matter what. The only problem with this is, actually I set it to false up here. I just have to return is equilateral instead of having multiple return statements. Again, preference is something that you'll pick up over time. You'll have your reasons why you want to do something or why you don't want to do something. Just be able to explain. And if I run it, I do get a failure. For which one? For 0, 0, 0. And that's because if 0 in size is equilateral equals false. Oh, so interesting. This is great. This is excellent. So this might be a reason why we would want to use that return. What's happening is it's running this bit of code here and it's setting this to false, but because I'm not returning immediately, it's also running this bit of code here. There are ways around that. But because I've already typed it, I'm just gonna Control Z and go back to what we had. So basically it's running this piece here and it's getting set to true. No big deal. I could add just a return right here if I wanted. But we'll just get it back to how it was because it was working. But no big deal. There's so many different ways to kind of handle situations like that. But we've essentially done what we needed to do here for this section, right? We've essentially done that. It works. Does that mean our code is perfect or even really all that good? Not necessarily. We are unit testing. We are testing this bit of code in isolation, and it does in fact do what we want it to do. So that's okay. That's okay. We just needed to make it work first, and this is okay. So maybe we want to put out some little notes here so people know what's happening. And we want to say check that no sides are of length 0. That's what maybe we'll say that here. And then here, maybe we just want to put a little thing in here that says check if all sides are equal to each other. Great. Way to do it. So we did it. We did it. We get a little more of this Bobby Boucher water. I'm not sure if the code is right. Run the test. Big facts. 100%. But again, code working and right is a little bit different, but yes. So is -1, -1, -1 an equilateral triangle? Great question. Probably. And we can check that. And so I can take this, and if you wanted to know, well, not if you wanted to know, if you want to know if our code will return that, we can see what our code will return. It will return that. They don't test for that test case, but we could check for that as well. And we could basically say, instead of if 0 in sides, we could just say if for this is how we could do that to check for that. We could say for side in sides, if side is less than 1. No, because we do allow digits. So we say less than or equal to 0. we allow floats, then we return false. So this would handle that test case too. Great question there. A standard error. So if we do this should still work. But if you want to know if it still works, you run your test again, and it does still in fact work. And this would allow it to work if we wanted to change up the numbers. So instead of 0, or let's add a new test to test that. And we want to say, hey, def test test no all sides negative, or something like that. Bad test name, to be honest, but whatever. Take self, and let's go ahead and copy one of these lines here, and we can extend our test to be great like this. And let's change it to, I'm lazy, I'm just gonna put a negative in front of all these instead of doing this, and we know that it should return false. And let's see that if we pass in negative numbers, if it does in fact return false as we expect. And so we added a brand new test case. We run our tests. 6 tests now pass. So check that out. That was a great bring up standard error. We've now checked for that. Again, there's probably easier ways to do that as well. But check if no sides are of length 0 or less. Cool, because you're right. Before we change this, that would have negative numbers would have returned true, in fact. So excellent. That's great. So we have that little bit of code right there. Now let's move on down to the next piece. Let's see if we can do the same thing for isosceles, and this can be a little more interesting. Actually, let's move on down to this part. So I'm gonna uncomment. I'm gonna comment this out, and I'm gonna go down here, and I'm gonna, this next class, I'm just going to simply do the same thing. So I'm gonna highlight 28 down to 54, and I'm gonna do control / again. And now we can check this. Now this is interesting. What's interesting about this is because now we're not testing that all of them are equal. So the paradigm in which we use up here to check just 2 of the comparisons may not be valid. Maybe because if we check this against maybe it might still be valid, but we're gonna have to have more test cases. So we might get down to this point, and we might start thinking about how to do this a little differently. And again, I actually don't know if this works. It's actually something I was just thinking of right, like as we were kind of starting this with Python, because of the way that Python works. And I only thought of it by looking at the test, to be honest, is that instead of actually comparing anything, and maybe we can change our first to do this. Let's actually change our first ones to do this to see if this works. It may not work across the board, but I'm thinking one paradigm of some of the data types that we have and data structures that we have in Python is that we have something called sets. If you take a list and you basically cast it to a set, it will remove duplicates. And I think that using that, I think that using that can allow us to easily figure some of these things out. And I'll talk through why. Again, I'm confident it'll work for equilateral, and I'm confident that it'll work for all of these actually. So let's see if it actually works, and let's see what I'm talking about. What I'm talking about is that actually, let's start with isosceles, and if it works, we'll go back and we will add it to this. So sides is a side. Actually, let me actually show you this. Because you probably may not know this. I don't know if we did this with sets, but let's say we go into, we're gonna drop down into the, this is going very slow. Let's open that back up. Ooh, this is, okay. Let's drop down into the Python interpreter. Nice. All right, and so let's set up a set. Let's set up a list. X is 3, 5, 9, 1, 4, 4, 9, 0. Let's go with that. So we have this list. How many numbers does it have? 1, 2, 3, 4, 5, 6, 7, 8. a list of 8 items, which means it has a what? A length of 8 items. And so we'll hit that. X equals that. If I print X, I have 8 items in here. But if I set X, if I cast X to a set, check this out. I have less items here. And what sets do is sets remove duplicates. And so there were multiple 4s. So basically we get rid of a 4. There were multiple 9s. We get rid of a 9. And now we have 2 less items. So now our set has a length of 1, 2, 3, 4, 5, 6. So it has a length of 6 now. I think we can use that to determine whether or not these things are working. And if this works, I'm very excited about this, because I would not have thought about this without looking at the test, for one. And two, I feel like people think about stuff like this all the time because Python isn't my language of choice. I generally think about things. Go makes you to be very explicit, and it gives you kind of the base level of tools, and you kind of have to do a lot of things manually. So I'm usually thinking about how to do things manually, and so I feel kind of cool for thinking about this, to be honest. So I hope it works. And so what we can do is we can determine an isosceles triangle says what? It says the 2 sides are equal. Let's go to the README, and everything's broken. Let's see, can I go to the README? Oh no. Oh no, we broke it. We broke it. We broke it. Oh, come on, fix yourself. Okay, it's all right. It's all right. We'll open it back up. Or should we just Vim it? Nah, we'll stay in VS Code. We'll definitely stay. Oh, my VM is having the time of its life right now. Oh, the problem is /snap exorcism 5. Yeah, I forgot to put it in a weird place. No. Okay, no, that's where it is. Snap go. No. Snap. I don't know where to go. Where do we download it to? CD. Where am I? Snap exorcism. Current. Was it meta? No. Hold on. I don't remember where we were. If I just open up VS Code, we'll open it back where we were. Let's see. What do you mean? We broke it. We're here together. We have triumph together, and we have failures together. I'm going to restart this whole thing, but I don't remember. You know what it is? Here's what I can do. Where did it download? Oh no, I should have done that. I should not have done that. That might have just overwritten everything. 5 exorcism Python triangle. CD. I hope that didn't overwrite everything. But that's fine. Even if it did, this will still give us an opportunity to do what we need to do. Open it back up in VS Code. If VS Code opens, which it's not opening, so it looks like we're gonna have to switch to Vim already. Oh man, I really thought I was gonna be able to work with I really tried to give the VM another chance instead of using the laptop, but it's okay. It's okay. We're gonna Vim it up. Real quick. Open that up. And let's do that. Whoa. Let's get out of here. All right, so it overwrote everything that we did. That's not a big deal. Let's just start with isosceles, and then we'll go back and we'll fix what we did. So let's try isosceles. And I said, hey, I think sets are gonna work for this. So I'm basically gonna take the sides, and I'm basically going to say, I could convert it to a set, but I don't even think I need to do that. Isosceles triangles have 2 sides which are the same. That means that 2 of the numbers have to be the same. That means if we run a set against it, that means that the length of the set should be 2. Why should it be 2? So it means that for an equilateral triangle, when all the numbers are the same, if we run a set against 2, 2, and 2, the length should actually be 1. And if 2 are the same, it should drop down to 2. And if none of them are the same, the length should be 3 because we're passing in 3 items. So I'm gonna say if, what is in Python, is it len or is it dot length? We'll try len. And I'm gonna say if len of set sides. So I'm basically going to set sides and take the length of that. I'm gonna say if the length of the set of sides is equal to 2, yeah, I'm gonna return true, and we'll dig deeper into this to help us understand this. We're gonna say, all right, return true, and I'm gonna say if not, go ahead and return false. That's nice. I like that, actually. So what we're gonna do is here, I'm gonna go ahead, I'm gonna comment out this true v down, undo, escape. I forgot the I'm in the box here. All right, so there, and let's also do it here. Okay, so we have some tests here. I'll save this. Whoa, what is that? C tags, I mean, I found. That's, ooh. Oh, my RC is messed up a little bit. No biggie. Let's see. Sudo PyTest triangle. So if we run this, let's see what passes and what doesn't. Maybe this doesn't work at all, but immediately we get 5 passing tests. And again, true false can be a little bit weird. But we can take a look at what's happening here, and we can kind of check it out. So we get one, you know, we get the ones in here that passed, and we can check and see what those things are that passed. But basically it says, hey, this one came back as false. False is not true. So this one came back as false, but it should have been true. Now, this is very interesting. Take a look at the input there, and it did say isosceles have at least 2 sides that are equal, but remember in the README, it said at least. It said at least 2 sides. So it sounds like to me that every equilateral triangle, every single equilateral triangle is also an isosceles triangle, but not every isosceles triangle is an equilateral triangle, which is interesting. That is something that I did not know. So this is very interesting to me. So now we have a little bit more things to kind of go off of. So we read what we read, but now we have some more things to go off of. So now we can go down the line and make sure that we make sure everything is true. So this needs to be true, but this came back as true, but it is false. Why is that? It's because there's more in here that we did not account for. We started with a general, with kind of the first piece of it. We made some tests pass. We made it pass for things that, things that did have 2 equal sides, but there's some more rules in there. There's some more rules in there for about, when the sides are more than, more like add 2 together and more or less or something like that. So let's see if I don't know if the set stuff is still going to work for that, but actually, here's what we're gonna do. Actually, we're gonna reboot this. Sudo. We're gonna shut down this VM real quick. I know what the problem is, and we are going to real quick. We are going to settings, display. We're gonna remove 3D acceleration. We're gonna start this bad boy back up. We're gonna get Ubuntu back up and running real quick. And again, I would just do this in Windows, but my desktop does not, it won't get WSL2 yet because they're still working out some errors. So yeah, it's an equilateral triangle, not a special case of an isosceles triangle. Yeah, I mean, now that's what I learned. I did not know that. So that's great. So we can check that together. The current code is missing that. Yep, exactly. The current code, the tests are good, but we are not handling all the cases that we need to handle. It's so frustrating that this VM is so trash when I gave it so much love. I gave it all of the things that I need. No, this has not been a VM the whole time. I've been going back and forth, Wally. Sometimes it's a V. Sometimes you're seeing a VM. Other times, one quick second here. Other times you're seeing this. Other times you are seeing this laptop actually being passed in through a capture card. I'm trying a couple different things out. I'm trying a couple different setups out for ease of use, and you know, some things work, some things don't. And it's leaning more and more towards us going back this laptop. This laptop is System 76 laptop. Again, it's you know, it's my Galago, you know, got stickers everywhere. I even got some stickers right in here, but it is running Pop OS. I really love this laptop, not gonna lie. Only thing I don't love about, two problems with this laptop. First one, that trackpad is some booty. It's not very good at all, but I have a nice mouse, Bluetooth mouse that I use with it, Logitech MX Master 2. And the battery life is subpar. That's generally a problem with Linux. You know, I mean, I can get, if I really want to get time out of it, I can get like 4 hours if I really need to. But yeah. And now check us out. I think, did we break this VM? Oh no. Okay, we're back. All right, let's see if I can get back into where exorcism is. Yeah, there we go. VS Code is nice because of the screen split. My finger, you know, my muscle memory isn't quite there yet for Vim to get my screen split good every time. I could just, you know, Control Z out of it instead of actually exiting, but I keep forgetting to do things. So we didn't account for what? For the, see, and this is the only thing that I don't like about, oh, never mind. So here it goes. It needs to be, so triangle itself should have a length, all sides should be greater than 0, and the sum of the lengths of any two of the sides must be greater than or equal to the length of the third side. So look at these test cases here. Why should these be false? Because if you add up 1 and 1, it's not greater than 3 at all. So we have one thing here, but we don't have, you know, we don't have the third case. Also, we're not checking for the length greater than 0 here. So actually, if we were to add this test up here, down here, it would also fail. So one thing you should be thinking when we're doing something like this, it says, hey, all these are triangles. All of this code is checking for triangles. So maybe, you know, if they have, if we're gonna need to write code that checks, you know, if something is a triangle, we don't want to have to write it for each of these things. So let's write ourselves a new little function to test these things. We're gonna say test def is triangle. Sure, we can call it whatever we want, and it's gonna take in sides as well, and we're gonna do something here. So the first thing we're gonna do is up top, we had it before but we lost it. What do we do? I think we said if side, oh, we did a for loop first. We said for side in the sides, if side is less than or equal to 0, then go ahead and return false. So that's good. So we're checking for that immediately. So, you know, we're checking for that immediately. And so that covers this first line here. But now we've got to do this. And the sum of the lengths of any two sides must be greater than or equal to the length of the third side. And so there are probably some fancy ways to do this. Let's brute force this now. Just say we brute force it before. And we can say if side 0 plus side 1. So that's adding up, that's taking the first two numbers and adding them together. And we're gonna say, hey, if that is equal, if that is, they need to be greater than the third one. If side 0 and side 1 is greater than, oh, wasn't there a third? Hold on, what was the other case? Greater than or equal to, okay, it's gonna be greater than or equal to. So greater than or equal to, side 3 There are better ways to do this. Again, same way we did the top one before, let's do this one the same way. So we're gonna say if side 0 and side 1 are greater than or equal to side 2, that's great. We want to return true there, but we can also do an and here like we did before, and we can say side 1 plus side let's actually keep it with side 0 and side 2. So first two, we're adding the first and the second, and then the second and after the and, we're gonna add 1 and 3. So we're gonna say if that's greater than or equal to side 1. So this can get a little confusing here. And we have one more case. So we took the first two, add them together. We took the first and last and add them together. And now we need to add the last two and compare it to the first. So we can add 3. We can link them all together. So a lot of stuff happening here. And like I said, there are easier ways to do this, but we're doing them this way for now because this is explicitly what we're doing. We're explicitly doing what we are thinking about. So and side 1 plus side 2 are greater than or equal to side 0. All right, so if all of these things are true, so we got a bunch of them here. If every single one of these is true, so this is checking if each side is checking all combinations of sides, and checking if they're equal to the last one. So if that's true, if all these things are true, go ahead and return true. And if not, go ahead and return false. All right, so now we have a little thing here that's going to check if that we can use over and over again to check if a triangle is true or false. I don't know if it's right yet. It's a lot of stuff there. We probably got something wrong, but it's okay. We're gonna find out in a second. Here's what we're gonna do. We're gonna take this isosceles section here, and the first thing we're gonna do when we get the sides, we're gonna say, go ahead and check if this thing is a triangle. And we're gonna say, if is triangle. And I think I can just say if is triangle, but we'll be explicit here. We'll say if is triangle equals true. Go ahead and do nothing. Go ahead and pass. Actually, let's do it. Let's do it this way. If is triangle is false. So if it's not a triangle, if it's not a triangle at all, we want to exit immediately. So we want to return false immediately here. But if not, we want to keep going. So we don't even need to add any other things. So we can say, hey, if when we run is triangle, if it's false, go ahead and return false, but we need to pass in sides to is triangle. So a lot of stuff here, a lot of explicitness here, but we'll see. Could you not just return the logic statement, or is that less readable? What do you mean return the logic statement? Oh, yes, we could. I believe we could return that. Yes, I'm just being as explicit as possible here, just to help walk through what we're actually doing. But yes, you are. I think you're right. I think we could just return the logic statement. It will basically be it'll evaluate to a Boolean value. You're correct. Just being, is it less readable? That's how I would prefer it. I would prefer it to be that way. I actually think it's equally, if not more readable, but again, it's not explicit and people might not understand exactly what's happening there. So cool. So we'll see if this works really quick. So basically, if it's not a triangle, so if is triangle is false, go ahead and just kick false back immediately. If not, go ahead and do the rest of the stuff that we talked about. And let's see if this works. I'm gonna be surprised if this works immediately because we're just writing stuff. We're again, just wild west code in there. But let's see if it works. PyTest. Actually, I think I have to sudo PyTest it. No, I don't actually. PyTest. Triangle. Oh, I have 9 failed here. Let's see here. You forgot to equilateral case for isosceles. Okay, I'll get to that, but we actually have 9 failing tests now. So why? Okay, we got a type error going on here. So we have a whole different thing going on right here. So let's see what's happening here. It says type error. int object is not scriptable. And so what it's basically saying, int object is not scriptable. It's not telling me exactly where, but it's telling me here def is triangle. 1 second. Is it not passing in sides? We can see this in a second. So takes in sides or side, and it's basically saying it's not scriptable. Let's see really quick what let's make sure sides is getting in here real quick. I just want to see something real quick. Let me see. Let me actually check. Equal to, and let's see. You want side 0 instead of, oh yes, thank you. Yes, for all of them. Yes, for all of them I want sides. Thank you. I was about to go down a long pipeline when it just, you know, nice and easy. It's because side is you know, it's not even a thing right here. Sides. Thank you for that. Save me a little bit of time. Let's go back up and remove this print statement. I want to make sure we were getting everything we're supposed to get. Which makes sense. 8 pass now. So 8 pass and 1 fail, which makes a little bit of sense here. Why? Because someone called it out before. Larry called it and says, hey, you did not handle that equilateral case accordingly. So let's take a look at that. And we said, let's look down here, and this case right here, we did not handle this case. So how can we make this pass? Again, all isosceles, all equilateral triangles seem like they're also isosceles triangles. So let's put a thing here, and we can say if the length is 2 or the length is 1, really. So we can check for both of these things. I wish you could do, I wish I could just do something like this. Can I do this? Actually, can I do something like, can you do something like this? I don't think you can do something like that. I have no idea, but it's 2, or let's copy this and paste this in here. It's 2 or 1. We can go ahead and check that out. And let's see if this runs really quick. And now we have non-passing. Again, not the best way, not the cleanest way, but we passed all of the cases. And you know, we've gotten a little bit cleaner from the first one, and we can go back up and add some things. Now that we've tried the set, we can add it to the top here. If in 1 2, that makes perfect sense. It makes perfect. I actually like that. I like that paradigm for Python. So let's see, like len like this. Will this work? Is this what we're talking about here? And that does work. Thank you so much. What's up, Zachary? What's up, Jaguera? What's up, Davizi? Welcome to the channel. Good to have you all. I've been, you know, all over the place, so I ignored that a little bit, but good to have you. Good to see you. We are making our way through a little bit of Python testing. It's really nice. I'm sure you got some Go stuff in a little bit as well. But yeah, also some fun things you can do with range. Yes, that's cool. So you don't have to create a list. That's fair. I like that, actually. Set a size in range of 1 to 2 plus 1. Okay. I like that. I like that. What's up, Rad Cullen? Dropping in real quick to say what's up. Hey, I appreciate you coming through. Absolutely, we're doing our best here. We're doing our best to, you know, to fight through some exorcism problems, but just to really kind of understand the premise of TDD and how you're going to run through it. So we're just running through it. So we've gotten all of our isosceles stuff to pass. I don't know, what's this warning thing? It's bothering me. Could not write. Oh, that's because actually it's because of this. I think it's because of the sudo. Sounds like a permissions error to me. And confirmed. Or is it confirmed? Yeah, confirmed. Permissions error. Yep. all good. So those are passing. So we have our isosceles triangle test passing. Let's go back up and apply our same logic really quick to the equilateral, since we lost that code a little bit ago. So what we'll do is we'll take all of this, actually, we'll copy it real quick, we'll paste it here, and gross. So we still need to check if triangle. This is going to be the same across the board. We need to check if it's actually a triangle. The only difference here is going to be this equals, if it's equilateral, it will have to equal 1. And we might not pass all the test cases, but let's find out. Let's find out. And how do we check those test cases? Let's go ahead back up here and let's uncomment all of these things here, and we'll save it. And now we have all of our stuff for equilateral, all of our stuff for isosceles, and we'll go through. And oh no, we have an error here, invalid syntax. That's probably a copy paste error. Let's look and see what they say here. Error collecting triangle, test.py. What did I do? Error adapted. Where is this at? Paste in invalid syntax. Hold on, let's take a look at our files real quick. Oh, this is why. This is supposed to be a comment, and I uncommented the comment, which is problematic. So I recommented the comment, and boom, 14 tests pass. We are phenomenal. We have achieved the goal here, and we also did it, you know, a little bit efficiently. Look how we wrote a whole extra little function to use over and over again, so that we don't have to do this again. So we can actually just take this line right here. We don't even have to know what a scaling triangle is, and we can paste this code in, because we know that for it to be a scaling triangle, it first has to be a triangle, and we have some code that tests this. And so yes, we can make this part easier as well, but yeah, let's yes, this works for now. We can keep this as is. So let's start to work on our scaling problem. So what's a scaling triangle? Let's look back at the README so that we can be smart. And so a scaling triangle, all the sides have different lengths. And if all the sides have different lengths, that means that each of them are different. That means if we should turn it into a set, that it shouldn't remove any duplicates. There should be no duplicates in that set of 3. So the length of this should always be 3. And so doing a little, you know, following what we did before here, we can say, you know, grab our little if length code here, and let's put it in right here. And we say, hey, if length is equal to 3, go ahead and return true. We still need the return false at the end here. All right, so we got a lot of code here, and let's see what that, you know, let's see if that passes, if that makes any of these tests pass. We'll uncomment these tests. We'll run it. Oh no, we'll run it. 14 tests passed. I did not save this file, I guess. Is that what happened? Hold on. These are more tests. Where'd they all go? Did I delete them? What just happened? Oh yeah, I deleted them on accident. I saved them now. They're there. Don't delete things. That's a problem. You shouldn't delete stuff. And now we'll run it. And now we have 19 tests passing. So if this is a complete set of tests, if these test cases cover all the edge cases, we can be confident that we've done our job. Maybe you know, there could be edge cases that we're missing, but for all intents and purposes right now, it's working. And now, so it's good, it is working. But now that you have the code working, you can now be confident. You can take some time to look at it, and you can refactor, and you can be confident, as Jennifer said earlier, that as you refactor, you can run the tests again to make sure that the things that you're changing still work. The intended outcomes still work. to be that guy, but this isn't test TDD, as test TDD requires test to fail before writing code. Yeah, so correct. We did run this in the beginning to show that all the tests were failing. I wasn't just adding them. I commented them out just so that there weren't so many tests, like we could parse through them easier. But absolutely, Ted's absolutely right. Like, you want to write failing tests before you have anything. But exorcism, you get exorcism, you get that out of the box with exorcism. You get failing tests. You have no code, all the tests fail up front. We did see that they were failing up front, but we just added them in and commented them back in. But you're right, 100%. That's a really good point to highlight, though. A lot of people don't do that. We want to make sure the tests are failing first, but we did see them failing. Two Python nitpicks, if you don't mind. Absolutely. The return line 13 is over indented. Sure. Let's yep. Absolutely. And let's make sure that still works. I think I'm gonna need a snake case for variables and functions. See, yeah, I'm okay with that. You know, I'm a Go person. You know, I can do snake case here. But now I have to change all of them. Let's find and replace. Let's find and replace is triangle, and we want to replace that with is triangle, and replace all of them. We'll save it. Our test can tell us if it's still working, and it is still working. Very fair. Very fair. I really don't like snake case variables, but I get it. It's all a matter of preference. I'm running a book study group on TDD. That's awesome. That's really cool. That is fair. 100%. Jitter Ted. That's a very important piece of the puzzle. It's a very important piece of TDD to kind of run down those failing test cases. I think we did it a bit with the first one, and then we just kind of, you know, went through and did them all. But instead of doing a whole new problem, I'm going to download. I do want to, I want to show you guys what a testing framework and some of these tests might look like in something like Go real quick. So we're going to download this exact same thing with Go. And so from the Go track, and we'll just change the track down here to Go. And let's go back again, and let's go to Go, the triangle. All right, and we're gonna open this up and hopefully in a separate VS Code. Yeah, okay. So Go, you know, like I said, every language has their own frameworks, their own tools for running tests. Go, you'll see, instead of coming with 2 files, actually, what? I think it's supposed to come with another file. Where am I at? Am I in? This should come with a different file. Okay, that's fine. Yeah, it was a common paradigm to move the test cases out of here. Interesting. Okay, so Go looks, it probably looks like a lot more to you right now, in comparison, because it is. Again, you're a little more verbose. You're a little, you know, things are a little bit different here. The thing that I wanted to show you was specifically this, and I found that for some people this is a little bit more simple of a paradigm, where you do these things, you create a structure. So in Go you can create these things called structs, and it's basically like its own data type, and we can say, hey, I'm creating a struct and I'm telling you, I'm passing in these things. So I'm passing in you know, A, B, and C that are all float 64s, and so all these things have to be passed in float 64s, and I'm calling a specific I'm calling a very specific what's this thing called, a function here. So it's written in a little bit different of a paradigm. A lot of times people move these test cases outside of this file, so they'll move them into another file where the test cases will all be contained in this structure. And this one's a little bit different because it has a couple of different things you can pass in, but a lot of the times it'll have basically very simply it'll have a whole list of inputs and outputs. And the reason why I like this in Go is because now the code that's down here, basically is going to run through it's basically going to run through, you write the test cases to iterate through the test, you write the tests to iterate through the cases that you have. And then when you need to add a new case, you don't necessarily need to go in and add a whole new block of code. You don't need to add in a whole new function to be able to test that case. You only need to add in a new a new item in this list, in this slice here. So instead of having to write a whole def function and saying it should assert to this thing, you just do a little colon here, and then you say, hey, I want to test the equilateral triangle, and I want to pass in 4, 5 and 6 or something like that, and you can then test out if that works or not. It's just kind of nice. It's just a different paradigm. I don't think we need to dig too deep into it. We can also write this in Go if you want to write in Go, or we can grab something else a little bit different. Actually, we're not gonna write in Go just because I think there's so many different pieces here that we haven't touched yet in Go that I think it's gonna be confusing. Let's grab a one that's a little bit easier. Just again, I want you to understand the paradigm of what you're seeing rather than solve the problem. Let's see what one of the easier ones, I think Bob. What was Bob? Yes. Let's look at Bob real quick. I remember this problem. This one's surprisingly it's kind of tough, actually. There's one case that makes it tough. We're not gonna do it, but we're gonna look at this. I don't know what the tests look like, but it feels like these tests should be better, and they do this paradigm here. Take a look. And now they have these cases. They have a test.go, Bob test.go, and a cases test.go. And this is the paradigm in which I like. And again, the other one was exactly the same actually. But when it splits it out like this, it gets a little more. This is how I like to set up my test and go. Because again, in the test.go file, it says, hey, I basically want you to go through for range, basically for TT and range test cases. So this is how you iterate through. There's like a for each loop. So it's going to iterate through everything in the test cases, and this test cases variable, and the test cases variable is right here in this other file. But this is how you iterate through it. It's going to say, hey, all I want you to do is iterate through everything in there, and then I'm going to set the actual value you got to me running this function. So I'm going to run this hey function from the actual code. So in the code over here, there's this hey function, and it says, hey, I'm going to run that with the input from TT. And so each item you get out of test cases, there's going to be an input column. And look at this, look at the struct here. The structure says, hey, I need you to set up a description, I need you to set up an input and an expected. So it's a clean paradigm. It's a pretty clean paradigm here. And again, it allows you to, it's going to loop through that whole thing, and it's going to say, hey, if the actual is not equal to what's expected, go ahead and give an error and go ahead and fail that test. So you write this little bit of code. And again, this is not feasible for all testing, but this is just the simplest forms of testing. All right, peace out, Genotech. Go get some dinner. Hope you enjoy it. I gotta make some dinner tonight. I don't know what I'm gonna have for dinner tonight. Last night I had some I had do piazza. I don't know how to pronounce things. But I usually go to an Afghan place called the Kabul. I went to the grocery store, got a little do piazza sauce, and diced up some chicken, poured it on there with some rice. It was pretty darn good. But I hope you have some great dinner tonight. I hope you have some great dinner. I want some good dinner too. Zufo, what are your thoughts on Go syntax? I like it. I think that so far, I think things are starting to change as Go is getting more mature. But I think that the syntax is as simple because they kind of focus on what was needed. I like it. I like it a lot. Actually, it makes sense to me. It makes sense to me. I like it. Peace out, Sandpaper. Have a good evening. I like it. It is a little it's a little jarring, but it's only jarring again when you're coming from, it was only jarring to me when I was coming from something like Python or Ruby or anything like that. But as I've been diving into Rust and stuff, I'm like, I think Go syntax is nice. I think it's nice. And again, the more and more you start to work with anything, it'll start to just feel more comfortable. I don't know if I'm saying that only because it feels like home, but I don't know, just because I'm used to it now. I like it. So again, what's nice about this is this file right here can stay the same. And if I want to add a new test case, I simply just add a new one of these, a little block here, a little block that says, hey, this is the description of what I'm testing. And here's the input I want to pass in, and here's the output I expect to get. And it makes it really easy to add as many tests as you want. So yeah, I think it's pretty cool. I kind of like that. What is this? I don't remember what this problem is. Let's see what this problem is. Do we have time to do it? Not really. Not really. Maybe we can start real quick. So Bob is a lackadaisical teenager. First, let's run this test. I actually don't know how to run these tests. Was it go run test or go test? I think I just run go test, and they all fail. Check that out. And it lets us know the first one that it fails on. Yo, Wally, thank you so much. Oh, that is the first off. Thank you for the bits. Amazing. But even better, I really like the little unicorn. I don't know what that is. Little unicorn snowman. I love it. So consistent and generous. Love your stuff. I genuinely appreciate it. I appreciate you. I appreciate your generosity. Thank you so much. 10 emotes shared. I love it. That's like, I love that emote a lot. Oh, Pride Pop. Oh, amazing. This is fun. Emotes are my new thing. I love emotes now. Pretty dope. I really do appreciate you, Wally. You are amazing. So immediately we get a failure on the very first test case that fails. And so this might work a little bit better if we were trying to follow down this test case. We get to the very first one. It says, hey, failed expected Bob failed on stating something. This is the input. Expected Bob to respond whatever. And so we can look at our Bob tests, our test cases, and look at that very first test case. And again, this is stating something, there's a description, so we know which one it's on. This was the input, and we expected Bob to say whatever. But right here is what Bob's actually saying. But it got nothing. Bob's not saying anything. Why is Bob not saying anything? Because we didn't tell Bob to say anything. And maybe we can just do one real quick. Let's do a few real quick to see if we can solve them real quick. So what is this? Bob is a lackadaisical teenager. In conversation, his responses are very limited. Bob answers sure if you ask him a question such as how are you. He answers whoa, chill out. If you yell at him, he answers calm down. I know what I'm doing. If you yell at him with a question, he says fine, be that way. If you address him without actually saying anything, he answers whatever to anything else. So this is a catch-all. There's a little catch-all right here. Say whatever. So we can start by doing, just solving this. So to solve this, yeah, we can say, hey, return whatever. I mean, it's that simple. It's that simple to solve this test case. So whatever with a period. And it takes in a string. Oh, I might have to use it actually. So we'll see. I'm pretty sure I'm gonna have to use it. So this might fail. Run go test and check that out. It did actually pass this one. I think there's a way to see what hold on. Wanted to show, yeah, verbose. I think, no, I thought that would show everything. I don't want to run the benchmark. Not that serious. Go test. I don't want to benchmark it. Let's see. Go test show all. Was a dash list. Go test dash V. Yeah, I didn't do anything. Yeah, I was expecting to see dash V. Why didn't that work? Let's go test dash. That might be because of the paradigm that we're doing it, but just gonna. So what is this? What does dash list do? Missing arguments. Dash dash. Go test. Help. Whoops. Go test. Dash dash help. Go test. Go help test flag. Oh, go help test. Reading is fundamental. So let's see. Args in addition. Oh. Only if you don't mind. What sets exorcism apart from other websites like LeetCode, HackerRank, Code Wars is the mentoring. That's very true. I always forget about that. Once you're comfortable with your solution, you can submit it for review. It may take a few days, but then someone comes takes a look at it. 100%. I think we covered that a bit, but I did not harp on that much. Especially because right now they said that mentoring is going to be a little bit slow. But it's pretty dope for one that you're a mentor. That's pretty awesome. I love that. And I found it to be super helpful for me. It was very helpful for me when I was first learning Go. I was able to get things working, but the mentors, they give you really good feedback about, hey, like, I saw that you did this. It's fine, it works. But maybe next time you could try something like this. And almost every time it was a very constructive, learning experience. It was like, oh, I didn't even know that was a thing that was available to me to use, and it allows you to go down different roads of learning new things. 100%. That is a big thing of exorcism. If you are someone who feels like you are, you're at a point where you can provide constructive feedback, to help mentor people through their solutions, I highly recommend you, utilize your skills to go and do that. Because again, exorcism is a phenomenal. I really do love the platform. I really love the platform. It's pretty cool. But like I said, their responses may be slow right now because they are working. The mentors are actually helping build version 3 of the exorcism, site and platform. So that's pretty dope. Thank you for calling that out. I appreciate that. I want to call you Sven Ben Schleifer because there's an S and there's a 7, and whenever I see S and a 7, I think Sven. Avenge Svenfold and not Avenge Sevenfold. I hope I said that right. But thank you very much for that. That's very true. Why aren't these giving me my verbose output like I'm expecting? It might be because of the way I'm passing in the input, but now I can just go down. It did pass the original one, so now it's going to shouting. It's going on to shouting, so we can see which ones it passed because it's going to go through these in order. So stating something, it got past that, and it got down to the very next one, which is shouting. So now we can try to handle shouting in 3 minutes. We'll try to do it in 3 minutes, so we have 1 minute to wrap up. So let's handle shouting. And so how do you know someone's shouting? And you know that someone's shouting if they this is the input, and they say watch out, so all caps with an exclamation point. And the way that there's a number of ways you can do this. There's a lot of ways you can go about doing this. There's complicated ways and uncomplicated ways. The way that I will probably do this is to say, hey, I'm gonna take the input, I'm gonna uppercase it all, I'm gonna capitalize everything, and I'm gonna check if what was passed in is equal to the same thing with all uppercase. Because if it is, then it's uppercase. That's one way to do it. I've seen people do it where they're checking, where they actually convert them into runes and check the ASCII value of each of them to make sure they're in a certain range. There's a number of ways to. There's a lot of ways to do it. There's in some languages, there's probably paradigms to just like check that. But in Go, I'm going to take you to the, I'm not just going to do it. I'm going to take you to the Go docs real quick. There's a strings package, and you might want to just Google something like Go uppercase string. And there's a strings package we're going to need to pull in to do this. How to convert a string to uppercase in Go. And again, when you do this, you just, it's okay to just Google and see if you can find your answer. And we're going to use the strings.toUpper to do that. And Go docs are, you know, a little bit tough to kind of understand. But we're basically going to import the strings package and we're going to toUpper it. So let's see if we can do that real quick and have a little fun with what we're going to try to do. Actually, okay. Let's just go play around real quick so you can see this in action. Go playground. Super fast. And so I can say, all right, instead of setting, let's set X is equal to hello playground. And what we're gonna do here is we're gonna say, we're gonna also, we're gonna do I have to set this equal to something else? What do they do here? Can't remember. I don't do a lot of string methods. Yeah. So we're gonna say uppercase X is equal to strings dot, what was it, just uppercase? I can't, or is it toUpper and pass an X, and then if we format dot println what uppercase X is, format imports, come on, import for me. Really? This is a comma, never remember, comma here, format, run. Undefined strings, let's see, what am I doing here? Yeah, strings, I brought in strings, I enabled formatting, strings dot, oh, capital T-O, okay. Capital T-O, I don't really like that this is capital. Undefined, oh, this time it didn't, import for me. There we go. And so down here at the bottom, you can see that it uppercased everything. And so what we can do is we can say in our code real fast to just make this test case pass, we can say, all right, instead of just returning whatever, we're going to say, hey, if what's getting passed in, remark is the thing that's getting passed in. And we're gonna say if actually, can you do this? One second. Can you do, I don't think I can do this because I have to actually call the strings package here, but let's try this real quick. Actually, that's not what I meant to do. Nope, no, you can't do that because you have to pass it in. So here's what we're gonna do. We're gonna take in remark real quick. There's an easy way to do this too, but we're gonna take in remark so we can do it fast. We're gonna take in remark and we're gonna make it equal to X equals remark. Actually, I'm tripping. I'm gonna say X if X, if strings dot dot toUpper, if strings dot toUpper of remark equals, we're gonna say if that's equal to remark. So if remark is already capitalized, then it'll already be upcased. So we'll say if remark basically is equal to strings dot upper remark, then go ahead and let's set response. So we'll make a variable called response and we'll set that equal to an empty string for now. And here we'll say then set response. The response is now equal to, what are we supposed to return in this case? In this case, we're supposed to return, whoa, chill out. And there are fireworks going off outside, very loud. If strings toUpper equals remark, go ahead and send response equals whoa, chill out. And then I'm gonna say down here, I'm gonna say else response equals whatever with a dot, and I'm gonna return response instead. And what is this? This is need to be in undefined strings. If I save it, it'll add import strings. Yes, it gunshots and fireworks, fireworks during this time of year are very common in Baltimore. The most common. I'll tell you when they're different. It's very, very gotta get ear for these things. So real quick, let's see if this works real quick. So I'm gonna set the response to whoa, chill out. If it's uppercase, and this one or whatever if so. So let's see if it passes these tests. No idea if it's gonna pass. But look at that. It did not stop on the same one. It dropped down to the next one. So, we did in fact pass this. It said, whoa, chill out for here. But look at this one. This is also one where capitalization should give us whoa, chill out. So it passed that one as well. But what it failed on was asking a question. And so we would just go down the list and we would continue to iterate and modify our response until we had all of them complete. And again, we would have to refactor a lot as we went through, but that is kind of how test-driven development works. And I encourage you to try to do this with, again, the language of your choice. Try to grab one of these and to start to do that. And the way that you would, you might say, how would you check if something is a question? Again, question mark makes it a question. Question mark at the end makes it a question. So this is a string. Remember, in Python in particular, I think you can refer to a letter by its index space. That string is an object in Python. Not necessarily sure that's the thing here, but you can check if the last item is a question mark in Python. So just keep that in mind if you're trying to solve this Bob problem. And there's a number of items in here, but you don't want to just check for the existence of a question mark, because a question mark could be in the middle for some reason. But yeah, there we go. That is test-driven development. So tangible takeaways for this evening is that, one, software testing is a way to confirm that the software that you're writing, the software that is written, is performing its intended task. Not working software does not mean it's performing its intended task. But software testing is ensuring that the code that has been written, that's been created, performs the task that it was intended to perform. We're talking about a couple different types of testing. We're talking about manual testing, which is the one that a lot of people think of. That's, we write the site, we hop onto the site, we click around, make sure the button goes to where it's supposed to go, make sure that the images pop up where they're supposed to pop up, things like that. Then we talked about automated testing, where we take that manual process and we automate aspects of it. It's possible to actually automate the entire thing. Again, there's a lot of tools and frameworks to allow that. But it's a way to be able to have confidence that your stuff is, again, doing what it's intended to do. We talked about different pieces of automated testing, two pieces of automated testing when there are a lot of them. Again, unit testing, which is testing the individual units of code and what they do. So that's what we've been doing here. We've been testing the individual units of code kind of in isolation. And the integration testing is testing all of the pieces together. It's bringing in those individual pieces and testing them together to see if they work well together. These are two very important pieces of the testing puzzle. They both need to be done. Then we talked about test-driven development a little bit, and we talked about that test-driven development is really a methodology. It's a way of doing things. It's a practice, and it is a practice of writing failing tests before you start writing implementing any code to solve the problem. So it makes you think through what actions need to happen to solve the problem that you're trying to solve, and you write failing tests, and you write your tests, and then after you write failing tests, you go through and you begin to write code or implement code that makes each of those tests pass, and you iterate over those. So you make one pass and you go to the next one that's failing, and you modify your code, you iterate over your code, and you refactor your code to make the next one pass, and you go through and you do the same thing again until all the tests are complete. Again, whether or not it's beneficial, I think it highly depends on the person doing it. But again, it's a practice. It can provide benefits in certain situations, and it's better for some people. And that's what it is. And we went through, we know that exorcism has this practice. They give you tests to help you formulate your decisions and help you understand how to approach these things. Having this knowledge really helps you know what to name. Like, not only does it tell you what to, like, the input and output, it also tells you in here what to name your functions. So it's going to be testing the hey function. So if I actually change the function in here to something different, it's actually going to fail. It's not going to work. So you actually need to have, like, it'll tell you what you even need to name your functions. So that's good, because sometimes Exorcism will not give you any stub code, and you have to code to make those tests pass. So you need to know what to call the functions. And again, that information can be found in the test somewhere. Not something you should be a pro at, after just watching what we just did. It can be a complicated topic. It can take you years to get good at it. But again, practice it. Most companies, most organizations implement some type of automated testing for their definitions of done. So before a ticket or before a feature can be done, be completed, a test usually need to be implemented for them. So it's something that you'll need to do. It's something you pick up over time. Every language has a different framework, different structure. Pick one, use it to try to understand what you're doing, and those concepts apply across the board. The implementation, again, the syntax is different, but what you're actually doing is the same pretty much across the board. It does get deeper than just checking input and output. It gets a lot deeper than that, to be honest, but this can really help you. This kind of the base level to start it, and can really give you a lot of confidence right out of the box. Input and output. When I pass this in, I should get this thing out, and you can use that to cover a lot of use cases. But that's it for tonight. I hope that everyone got something out of TDD. It's an interesting topic, but we are back on next week with congratulations, you're done with week 7. I highly encourage that you go in and you read Ted's article. I'm going to read Ted's article right after this about TDD, because it's always want to learn. I want to get better at building software, and I think that learning how to test better will help me get better at software as well, and I want to know these things. But congratulations on finishing week 7. We're back next week with errors. We're talking about errors and error handling on Monday or on Tuesday, and on Thursday we're doing an engineering panel. So come with your questions ready. We're gonna have engineers of various levels here, software engineers, different pieces of the industry, big companies, small companies, beginners, intermediate, experts. We have a panel right now. The panel's gonna be around 5 people. It's been bigger before, and that kind of sucked because everyone wanted to answer a question, each of the questions, so we didn't get through as many questions. So I might cut it down to 4. I might have to cut somebody. We'll see. So that is on Thursday, but on Wednesday the DevOps engineering panel is happening as well. I encourage you to come to that one too, even if you don't care about DevOps. DevOps kind of plays into software really heavily, and you need to be familiar with those things if your goal is to be a software engineer. So I'd recommend you come and check that out as well. But yeah, this Saturday, actually, last announcement, this Saturday is the Live Coders conf.livecoders.dev all day here on Twitch. We actually have the front page of Twitch. I am a part of the Live Coders group here on Twitch. You can kind of see it at the bottom here. So mine is at 12:30 Eastern time. I'm going to be watching all day, checking out a lot of different people, meeting a lot of different people. I encourage you, if you have time while you're doing stuff, check it out, because you might find someone who you really connect with, who does some cool things that can teach you a lot of stuff, or is building something cool that you're interested in, where you can apply the knowledge that you're learning here there, and kind of understand those things. So I just encourage you to just get out, explore, and I think the talks are going to be good just to contextualize the things that you've been learning and help you get up to speed on more and more things. I think it's going to be pretty exciting. I go on at 12:30 Eastern time, so right as people are in lunchtime, right around there. So come on through. A quick 25-minute presentation. Again, DevOps will do a live movie trailer edition. You're going to get to see an entire DevOps pipeline. You're going to see an application go from my computer, go run through an entire pipeline into the cloud working. We're going to be pushing changes and everything, but mostly you're going to learn about the pillars and the ethos of DevOps through movie trailers. It's going to be fun. It's going to be exciting. It's going to be super exciting. But let me send this over if you want to check this out. And it's gonna be amazing. I'm actually really excited about it. I think I like Twitch because it's gonna give me the freedom to kind of do. I've never done a talk like this. I've only ever done one real talk, to be honest, and that was like last week. So it should be fun. But that's it. That's all I got for you all. Another little thing, little thing. Right after these are done, we're actually going to be probably rolling back into Pipelines, which is the bootcamp that was running on Saturdays, which we had to postpone. More information coming about that soon, probably the very next week after. There's also going to be a Linux bootcamp coming up. It's probably going to be around 4 weeks, probably a 4-week Linux bootcamp. As well as we're working on some HashiCorp stuff as well. So if you're interested in purely Terraform, we're possibly going to be doing a course that caters to, they have an exam now, but that not only caters to the exam, but that covers Terraform pretty heavily, as well as a little Docker bootcamp coming up, a Docker and Kubernetes bootcamp. Docker first. The Docker one will probably only be 2 weeks long. 2 to 3 weeks long. I'll let you know. So if you're interested in those things, look out for information. Those things are going to be coming up very shortly, because we'll have a little flexibility when we get to the end of these boot camps, and then I'll give you more information as it comes up about when the next levels of these boot camps are coming up, because those are not too far off in the distance either. But that's it. Everyone have a great night. Who are we going to head over and raid tonight? Appreciate it. I appreciate all of the I think you provided a lot of great guidance tonight. I really appreciate it. I always tell people, hey, whatever you can, we're a community, whatever you can provide. I love when people can come and bring their input and are comfortable doing that. I learned a lot tonight about a lot of different things, so I really appreciate it. Thank you for giving me the encouragement of liking my enthusiasm, and I'll hope to see you in the future. Absolutely. Let's who are we heading over to see this evening? Peace out, everyone who's out of here. RW Grimm, who's is that the older guy who not RWX Rob, is this the dude that's like angry all the time and he looks like Gandalf? Let's see when we'll get through this ad. Let's see if this is there's a guy who looks like Gandalf who streams, and this is not. But let's head over to RW Grimm, doing some sweet programming on Pigeon. Pigeon's pretty dope. Let's see if I actually have Pigeon on here. It doesn't come on here anymore, but Pigeon is a messaging application for Linux. I think it might be multi-platform, but let's head over. Elkarn, sorry you caught the end of the stream as well. This will be up on YouTube soon, but it's also here as well. Last Miles, I've seen Last Miles before. Is Last Miles on? Not live right now. Let's head over to RW Grimm. Oh yes, Last Miles. Yes, that is, I think that's it. Yes, I was like, it sounds familiar. But yeah, let's head over and let's raid RW Grimm. Let me get the typing ready. Get your emotes ready. / raid RW_Grimm. Say hello. Everyone have a good evening. Enjoy yourselves. I'm gonna go work on my talk. Make sure I can deliver it in the way that I want to deliver it. But peace out. I'm gonna get some lunch. Some dinner. See, it's late. I'm gonna get some dinner as well. We're out of here in 10 seconds, 9 seconds, 8 seconds, 5 seconds, 4 seconds, 3 seconds, 2 seconds, 1 second. Peace out, everyone. Have a great night.